Climate change is leading to increased energy expenditure, particularly in Central and Southern Europe. Buildings are responsible for 40% of the EU consumption and 36% of greenhouse emissions. Over 30 million Europeans struggle to pay their energy bills. The EU renovation wave aims to reduce energy consumption and avoid energy poverty.
I traveled to Italy and France to discover HEART, an innovative toolkit that aims at transforming existing buildings into smart buildings, thanks to a cloud-based computer system.
In the Italian province of Reggio Emilia, in Bagnolo in Piano, I visit the first building transplanted with this energy-efficient HEART toolkit. This public housing building, built in 1985, is turning into a smart building. But what is HEART and how does it work? Every HEART building includes an insulation system, photovoltaic tiles, high-efficiency water storage tanks, smart fan coils, battery packs, and hydronic heat pumps. All components are interconnected by software that analyzes the different energy consumption options. The renovation started 2 years ago, after thorough research led by the Polytechnic University of Milan together with other partners. I meet the tenants to learn about their experience. Grazia Di Bella has been living here for 25 years. She can feel the difference both in her pocket and in her comfort inside her house.
Io penso che quando è finito tutto qua, io penso che non abbiamo più bisogno di niente, perché proprio hanno fatto un capolavoro, veramente. Ci hanno dato tutto, cosa vogliamo di più? L'energia è stata già diminuita, tantissimo.
This social housing residence belongs to ACER, the public housing company in Reggio Emilia. Marco Corradi, its president, acknowledges the tenants' collaboration.
In questo progetto è stata molto importante la collaborazione che abbiamo avuto con gli abitanti, con i residenti, perché sono poi loro stessi che ci hanno raccontato quali sono le esigenze della vita quotidiana nell'utilizzo dell'abitazione.
The work has not been without technical setbacks. The system tuning has been criticized by some tenants. Silvano Salci is a pensioner who has been living here for 33 years.
Sinceramente hanno tribolato molto per farle andare e per trovare la temperatura. È come il trapano che sta fuorendo ancora i buchi per i pannelli, insomma. L'abbiamo pagato sulla nostra pelle queste cose.
The renovation and the system implementation are complex processes that went through some difficulties. I meet Ercole Finocchietti, the leading engineer of ACER, who knows every inch of the site. He's responsible for installing the HEART experimental system in Bagnolo.
È un po' complessa l'organizzazione, soprattutto si tratta di un progetto pilota, quindi qualche problema in più c'è. Comunque è un sistema sperimentale e necessita di un tuning molto fine in opera.
Ercole shows us the heat pump, tanks, pipelines and the rest of the components installed in the basement. All of them are interconnected with sensors that send consumption data to the cloud-based system. In Bagnolo we discovered the heart of the project, the MIMO, Multi-Input, Multi-Output.
Multi-input significa che raccoglie dati da tutti i sensori in campo, sensori in casa, in centrale termica e sul tetto. Il multi-output è che ricevendo questi sensori analizza la situazione e gestisce quindi dando i comandi alle pompe della centrale termica, anziché le pompe di calore in casa, anziché al fotovoltaico deviando l'energia verso le batterie o verso i sistemi di utilizzo.
Both in Italy and France, the pilot projects have been carried out in social residences that are very energy intensive. The goal is to improve inhabitants' comfort and to reduce the energy poverty gap.
Noi abbiamo oltre il 50% delle famiglie che vivono nelle nostre case dove riscontriamo il fenomeno della povertà energetica, che è un problema anche di benessere, oppure diventa un problema per noi perché quando l'inquilino non è in grado di pagare le bollette, i costi del condominio, siamo noi che andiamo a sostituirci con la copertura delle spese.
only 1% of the EU building stock undergoes energy-efficient renovation every year, so action and innovation is crucial to make Europe climate neutral by 2050.
Non bisogna aver paura dell'innovazione, ci vuole anche del coraggio. Noi abbiamo segnato una strada che dobbiamo perseguire nei prossimi anni con molta determinazione, perché questo rappresenta il futuro delle nostre città.
At the outskirts of the city of Lyon, in Saint-Priest, there is a second demo site. 26 apartments built in 1975 owned by the Est Métropole Habitat, the public social housing of Lyon. This site started 1 year later than the demo in Bagnolo. I meet Romain Levard, the leading engineer of the site, to show me around. He deals daily with the tenants' concerns and the challenges of the construction.
I think the main key is communication with everyone to make sure that we are able to do the works inside their apartment. You have to build trust.
José Ferreira has been living in this apartment for more than 10 years. He is skeptical about the benefits of the renovation.
Je vois pas ce qui a changé. Hein. On payait plus cher. Alors aujourd'hui, parce qu'on n'a pas de chauffage, on a juste le chauffage électrique. Et la nuit, il fait froid, quoi.
COVID caused logistical delays, therefore the computer-based system MIMO has not yet been installed at the Lyon site. Moreover, the French building needed a further renovation of the insulation elements. The rooftop and the basement have been insulated and more efficient windows have been installed. Despite the large amount of work, some tenants believe it is worth going through with the renovations. Nelson Faria is an agronomist. He thinks the insulation has improved the heating quality, even if the transition from gas to high-efficient energy has not been done yet.
Il y a eu des différences, ça se voit parce que avant il faisait trop froid. Il a maintenant fait froid, mais pas trop, parce qu'ils n'ont pas encore fini. On est pas sur les gaz, mais on est sur l'électricité. L'électricité, c'est un peu cher quand même. Mais une fois qu'ils vont mettre en marche la chaudière en eau chaude, ça va voir la différence en fait.
Nelson's door-to-door neighbor, Tohami Wazani, is concerned about his comfort, but also about climate change and energy consumption.
J'espère qu'il y aura moins de gaspillage, que le climat, l'énergie, c'est indispensable pour vivre. Donc il faut qu'on la préserve, la terre entière. Et il faut préserver les ressources. Si on les gaspille, on les consomme d'une façon irresponsable, c'est vrai que c'est un problème.
One of the strengths of the project is that tenants didn't have to leave their homes during the renovation work, as explains Temil Gesserimi.
Pelo travaux, je restais à la maison. Les personnes ont fait tout, la maison, la peinture, les travaux, tout que besoin. Moi, je restais avec mon copain à la maison. Et pas me dérange. Non.
In addition to the renovation elements, the data collection system is the flagship aspect of this project. Mohamed El-Mankibi, the research director of the National School of State Public Works, is leading the data mining and monitoring. The challenge is to find a way for tenants to feel comfortable using the technology and learning how to interpret the data.
There is a kind of balance to find between monitoring and completely knowing what it is happening and communicating with the occupants in order to make them confident and not be like a big brother that is monitoring everything they are doing.
Niccolò Aste, full professor of architecture and engineering at the Polytechnic of Milan and project coordinator of HART, is visiting the site in Lyon together with other partners. He feels hopeful about the results of the project.
HART è stato pensato per risolvere il problema della ristrutturazione energetica di un'enorme quantità di edifici che risalgono alla seconda metà del secolo scorso, che sono stati costruiti con una qualità energetica molto povera. È un sistema molto innovativo che entrerà, e noi speriamo che lo faccia, in competizione con altri sistemi, però una quota significativa siamo convinti che sarà nostra.
Innovation takes heart. The goal is to transplant this high-efficient heart system into the EU's old building stock to achieve decarbonization and a greener future.
Well, I would like to welcome you all and delighted for the final conference of the HEART project. Today the whole event is broken down into 3 different sessions. In the session 1 we'll be looking at the project results and the toolkit that we have developed. In the session 2 we have guest speakers and presentation about pathway to decarbonization. We'll be looking at work towards decarbonization of building. In session 3, we have a policy discussion on how to promote smart building technologies in EU. Without delay, I would like to introduce the speakers for the session 1. We'll start with Professor Nicolo Aste, who is the project coordinator and also the chief researcher for the project. He'll be introducing the project and the toolkit. Then Claudio Del Pero, he's the project manager and associate professor at the Polytechnic di Milano. He will be introducing the technical system of the project. And then we have Angela Delgado from Garcia Rama, who will be presenting the envelope system. And without delay, I would like to, and then we have Gaten and Frederick from Useful Risk, who will present the cloud platform of the project. And then we have Fabrizio and Alice from Fabrizio from Polemy and Alice from Housing Europe, who will present the demo cases that we have in Italy and France. I would like to welcome Professor Aste to the stage. The next slide, the previous slide. Okay.
So, good morning. Thank you for being here with us. This is one of the last step of our project. It was a very tough ride, but we managed to come to the completion of our project, and also during the difficult period for all the world, with the pandemics, with the economics and politics situation, which is very challenging. But the consortium was very strong. We have good partners, and also the partnership has got stronger. So we became stronger after this period, and we hope also our system, also our heart system, can be reinforced from all our efforts. So, in brief, we have a lot of things to do today. So, just a brief introduction about the system and the different components. So we already all we know what is the structure of our system, which is an holistic energy and architectural retrofit toolkit. Also for our guests today, just to recap. And it deals with the renovation, of course, energy efficient buildings, and it is not so strange to think that it could be one of the solutions of this difficult situation of the last months. Our buildings are consuming around the 40% of the total energy consumption, and we and now we are aware of what is the cost, and not only the economical cost of the energy, and our system can cut on about the 90% the energy consumption of a building. So it is very timely to have developed such a system. And the duration has been almost 5 years. Is it right? So a very long ride. And yes, I'm the project coordinator, but the coordination has been made by all our partners all together. And the consortium is a very strong dream team all around Europe, with universities, industries, technicians, and so on. And the application context is a particular belt within Europe where the moderate climate requires the building energy performance to relate both to heating and cooling. And of course, the overheating we are experiencing in this summer demonstrate that this is the right direction of the research. Application target are multi-story residential buildings of the second half of the last century with 4 or 5 floors. And the objective were to develop a systemic solution which could be efficient from the energy point of view, but also from the economic point of view, and to develop, update, and adapt innovative solution by means of traditional technologies or the integration of different technologies, and then to allow to existing buildings to become smart buildings. And this was one of the strongest challenges. And of course, the heart of heart is our platform, which supports the decision making, the managing, and the maintenance, starting from the project until the end of life of the building. And also energy efficient financing is enabled from this kind of management of the building. This is the general scheme of our toolkit, with technologies for the replacement of windows, with the insulation, this facade system for the insulation and the retrofit of the external facade, with our BIPV tiles, of course the cloud-based platform, and then the smart fan coils, the MIMO, the multi-input, multi-output power controller, and the heat pumps, and so on. And all these components are working according to a synergistic logic to solve in a systemic manner the energy performance of the building. And we have 2 case studies, one in Bagnolo, which was the first in order of time, and the second one in Lyon. And the development of the building site was very difficult because of the pandemics, the lockdowns, the difficulty in materials and components delivery, and of course this was the most heavy part of the project. And I want to thank in particular who has worked in the building sites, because it was very not easy to come to the end of this work. But we were still able to finish, to complete all the works. And so, very briefly, thank you. We have a lot of discussion and focus to face today, and so I leave the floor to Claudio Del Pero.
Good morning. So I will do a quick deepening on the hard technical system. You saw let's say the introduction about the main components. I will skip the first two. I will focus on what we call technical systems, so the hardware related to the HVAC components to produce electricity and thermal energy in a sustainable way. So you can see here the hydraulic loops. I don't want to be too technical, but we have a heat pump powered in direct current directly by the photovoltaic panels that is generating thermal energy, so is heating or cooling down the water, and this water can be stored in a tank, in some tanks that are equipped with PCM, phase change materials, in order to store the thermal energy. And then we have a second loop between the tank and the smart fan coil, so the elements that are inside the dwelling to provide heating and cooling. More in detail, the heat pump works together with the photovoltaic system where we have the sun, where we have the solar energy. The heat pump is generating hot water or chilled water. And this thermal energy is stored in that PCM tank. When the sun is not available, for example, during the night and during a cloudy day, the PCM storage acts as a generator. So it's sending thermal energy to the loop where the smart fan coils are connected. So we try to avoid using electricity when the sun is not available. Then we have let's say quite complex electric system. The focus, of the system is the multi-input, multi-output converter. Is a sort of multifunctional converter that is connecting all the DC appliances. One of the focus of the HART project is that we produce electricity in direct current from the photovoltaic panel, and we use that electricity in direct current, avoiding conversion, avoiding all the transformer you have connected to your laptop, to your mobile phone, that are consuming energy, wasting energy, I can say. And also the MIMO is interconnecting the building with the grid, because obviously we cannot be autonomous. We need the grid, especially during the winter, depending on the climate. And so the converter is producing DC power at low voltage, 48 volt, so it's very safe. And we are sending this voltage to all the dwellings. And we are powering the smart fan coils. The smart fan coils are substituting the existing radiators. Then we are also producing DC power at 550 volts to power the main heat pump. And at the same time, we are connecting to the MIMO, the PV system, and the batteries, always working in DC. And then finally, we have the grid connection for taking power when it's not available, or also to sell extra power, for example, during the summer, where the photovoltaic production is much higher than the energy consumption. You can see here the structure of the MIMO. It's not only one component, quite big, and is up to manage, is able to manage up to 10 kilowatt of power. We can connect 10 kilowatt of solar panel, 10 kilowatt of batteries, 10 kilowatt of PV, of heat pump, smart fan coils, and also to manage an interaction with the grid up with 10 kilowatt. So it's a quite big and versatile system that is able to manage let's say, a small condominium. For example, in Bagnolo, in Italy, we have one unique MIMO for the entire building. It's made up 12 dwelling. In Lyon, the case study is a little bit bigger, so we have 2 different converters. Then I do a quick focus on the other technical system. This is the PV tile. You can see it's a photovoltaic tile. It's made by 2 main elements. It's a basic element made by recycled plastic. You can see with that orange-red color that is very similar to the color of the existing tiles, because the element is designed especially to substitute existing tiles in the tile roofs. And then the second element is a PV photovoltaic laminate. It's a customized photovoltaic laminate that is connected mechanically to the plastic tile, without glue, without any kind of similar components, just using mechanical connection. It's lightweight and is also, let's say, competitive under the economic point of view with the traditional PV system. And this is a BIPV component, building integrated system, so it's also waterproof. You can see that we are replacing the existing tiles with this new component. Here you can have an anticipation of what my colleagues will present later. So the 2 case studies, the first one in Italy and the second one in Lyon. You can see the 2 different colors, because in the first case we had the black backsheet of the PV tile. In the second case you can see the transparent backsheet. You can see through the glass and you can see the color of the plastic tile. So we did these 2 different variants. Then we have the DC heat pump in 2 different versions. Again, 15 kilowatts and 20 kilowatts. In both cases, the component is split in 2 parts, an indoor unit and an outdoor unit, to save space, so to have the outdoor unit as smaller as possible. And the power is DC, 550 volts. And we did an effort to have a low sound emission, to have an optimized design of the heat exchanger, to have modulating fan, to have a high COP also during the winter season with low temperatures. You can see here the 2 versions. On the left, the version we installed in Italy, and the second version in Lyon. You can see the second one is smaller because we had a constraint about the installation space, so we had to install the heat pump on the top of those new glazed element that was added to the building facade. Then the smart fan coil, that is that element substituting the radiator. So we are eliminating the existing radiator and putting this, that is in effect water to air small heat pump. There is a small compressor, like the compressor you have in your fridge at home, and it is able to generate heating and cooling. So in every room we can manage heating and cooling load separately. You can see here the testing phase. In the middle is the cover we have in Bagnolo, so we specifically developed for the Bagnolo case study. In the last picture you can see the smart domestic hot water boiler, because also the domestic hot water is generated with the same technology, with a small water-to-water heat pump, in this case, that is heating the water directly inside the dwellings. As I anticipated, the main storage solution are water tanks filled with PCM. This is why they are more sustainable than batteries. As an optional, we can also connect electrochemical batteries, but in this case, the cost is lower, the lifetime is longer, and also the efficiency is higher. So we really believe that thermal storage in buildings is the best solution, because we need to mainly deal with heating, cooling, and domestic hot water demand. And then, last but not least, the ICT interaction. All these components must speak together, must interact together. So we have an ICT structure. We have a building gateway inside every building. This building gateway is collecting the information coming from all the devices, and through an internet connection is connecting the system, the building, with the cloud platform. In particular, every device has a small interface that can work via Wi-Fi or narrowband IoT standard, and the information are transferred to the building gateway and then using a traditional ADSL modem to the cloud platform. This is the structure of the cloud platform. Is something that is not just used to monitor, to store the information, but also to interact with the user, interact with the stakeholders, and also to collect information, for example, about weather forecast, because knowing the weather forecast, we can establish which is the best control logic, for example, to store the electricity in form of thermal energy. So thanks for your attention.
Hello, I will be presenting the envelope solutions adopted in the HART project. I am Angela Llamas, a partner from Garcia Rama, and we were in charge of the modular facade thermal insulation. As it is well known, without continuous insulation, it leads to thermal breaches and loss of heat and comfort inside the homes, and that is why refurbishing with continuous insulation with lower thermal conductivity leads to slowing the heat movement through the building elements, improves the performance of the building envelope, helps achieving higher energy efficiency levels, and also provides better occupant comfort. Now let's see the different system components adopted in the HART project. The panel, of course, is one of the main elements. It's a sandwich panel with a polyisocyanate rad coat with very low thermal conductivity and good fire performance. The also tone and groove connection makes the insulation continue without creating thermal breaches. It is also watertight and an airtight joint. It also has a vapor barrier and high durability of 5 to 7 layers of finishing. It is also lightweight. It has less than 2 kilograms per square meter weight. That's why it's 3 times lighter than the ceramic cladded used, for example, in the ventilated facades. And it can withstand up to 3 kilograms per square meter with a span of 1.5 meters. Now let's see, Now let's see the substructure. This is some pictures of the French building in Lyon, where you can see the different brackets and profiles being installed in the facades. For the system, we adopted a continuum framing around the windows to create the aesthetics, and also in the right you can see that the solution adapted in the balcony was different, using composite aluminum panel, which makes the system more versatile. Also, we created a new solution for the HART project to speed up the installation. We designed the prototypes, we made the prototypes, and we did the extrusion of the different pieces in aluminum. And here you can see how everything is attached. The splice joint will go into the bracket, then the vertical profile will be attached into the splice joint, then the panels are placed and fixed, and then the finishing is placed to end the system. Here you can see the different finishings that are needed to end the system, like in windows, lintel, jambs, window sill, and corners. This is a picture of a building finish in Gijón, where you can see lintels, jambs, different corners, how the gas is covered as well. Now let's see what it needs to be done before the installation. It is very important to make a pull-out test on the facade before to check the tensile strength and choose the fixing accordingly. It can be a mechanical fixing or a chemical fixing if the facade is not strong enough. Also, some preparatory works are needed, like to check if there are cracks or different things, defects that needs to be fixed before the installation. And also, this is the moment where we integrate all the sensors, equipment, wiring of the hard project inside the air gap, which allows not inviting the homes. Here you can see how they would go after the panel inside the air chamber. And also, it is very important to do a building survey, to take some guidelines for the installation and taking measurements before the manufacturing. Here we can see Garcia Rama in the Italian building, making the building survey. I also have to point out the important advantage of the system, because it has modular properties, and this allows the installation without the need of a scaffolding. And here you can see pictures of the French and Italian building using lifting platforms. Also, we perform many work to help with the installation process, which is difficult. We made, for example, this video tutorial that you can see on the right. This is some Garcia Rama officials making a demo in a facade that we send to the people in charge of the installation, so they can learn how it's done, to put the brackets, the profiles, etc. We also made a serialization label system on the different components that we send, so they can be easily identified. Also, installation plans with codes to identify the elements, and many 3D tutorials step by step to help the installers and the people in charge of putting the facade. Now let's see the installation process in a simplified video. The first thing we have to do is put the brackets with a thermal bridge in the facade. Then the fixings are anchoring according to the dynamometric tests that we did before. It can be mechanical or chemical anchoring. Then the profiles are attached to the brackets. The panels then are connected to the profiles with a tongue and group connection, creating the air chamber. And then the finishings are placed, sealing the system and making the air gap airtight. Now I will show you the windows intervention that was done also in both buildings. It was in charge Michela Brusetti, also ZH. In Bagnolo, Italy, there was done a glass substitution, the mounting of new modified wooden gas stove profile, hinge substitution, gasket renewal, also a shutterbox insulation, and the exterior frame side repairing. Here you can see different pictures of the people working and making the renovations of the windows. And here you can see different pictures of the renovation in France, where they changed completely the windows with a PVC frame and double glass low emissivity glass. Yeah. And now let's see how everything was finalized in both buildings. This is the Italian building before renovation and after. This is the south facade, where you can see the balconies, and this versatile composite solution that we came up was adapted. Also, you can see the continuous frame used for the aesthetic of the panels, how everything is vertical. And these are some more views. The west facade of the Bagnolo building, and a close-up where you can see the different finishings for the continuous framing and the windows. And this is the Lyon building, one of the main facade. Here it was used also the continuous frame for the aesthetics, and also the composite panel in some windows, as you can see. And some other building, some other pictures. In this picture you can see that we use a folded panel in the corner, so we avoid the thermal bridge. This was done in both buildings. and that's it. Thank you.
Good morning, everybody. My name is Gaëtan Lurbeck. I'm working at Useful Risk. I'm partner of the ART project. I'm in charge of the ART Cloud platform for the project. So the cloud platform is a set of different tools that aggregate different stakeholders. So in the cloud platform, we are working with owner of building, with facility managers. We are working with the building system, external services like weather information, open data that we get from third-party libraries. We're also working with university and research centers to work on the model that we applied on the different buildings. With platform technical support, so the people we are working on installing the FineCoil, installing the MIMO and other device that is coming inside of the building. And finally, we are also working with the tenants. We are living inside of the building. So the cloud platform is really an aggregation of every different system that has been created for the ART toolkit. From the first first contact that we have with the customer, the owner and energy manager, until the tenant and the people we analyze, the university who analyze the different data that is coming in the platform. The way that the platform is working is really to take the different user along the whole process of integration of the platform. So the first part is the registration on the platform itself. So the user will come, register on the platform, have all the information about the different techniques that is applied, the different capabilities, and also the information about what the goals he could have and what the capabilities he will get out of his building after renovation. As soon as he went after the public information, he can get inside of a secure part of the platform where he will describe his building. So he will create a new project, and inside of that project will start a description of the building. That description starts with localization, to know about weather information, to know about specific climate that we can have at that moment, but also about the current envelope of that building, what is the system currently installed, about HVAC, about thermal zone of that building, the number of floors, number of dwelling. Also, we have information about, we ask to fill in information about what are the current consumption of that building, what is the energy, the current energy model of the building. And finally, we're asking about economical parameters. Okay. All those information allow us to have a 365 view of the building and being really able to create and put those data inside of the model to get further and make some proposal for the customer. As soon as we know the building, we can then describe the different targets that the customer have. So what are the different technologies that he wants to use? What are the amount of technologies? So does he want to use a lot of solar panels or only a little bit of them, because there are some environmental or legal situation where we cannot do a full installation? And also, what are the savings that he wants to achieve? Based on the budget that he has, based on some regulation might be. And when we get all those information, what we call the decision support system is triggered. Okay? And he will propose a different set of options for the retrofit. And the different options, there are about 20 different options that we elect from about 1,000 that are calculated by the model, will influence the way that the owner wants to retrofit the building. So it will take into account the environmental impact, but also economical impact and other situations when the owner can be related to. At that moment, the customer now has a choice to work with the art toolkit. Okay. It's that moment that we will decide, based on the option that is chosen for the retrofit, what are the number of fan coils, what is the number of heat pumps that need to be bought for the project itself. Okay? So we are coming at that moment inside of the contractual phase of the project. Okay? That's where we will really take all those information, work with the older partners to really create that project of retrofit for its own building. Mm-hmm. Okay. So as soon as the contract is signed, we can start retrofitting. So there is a lot of time, depending on what has to be installed. But you know that changing the facade, changing the fan coils, changing the boiler inside the building can take some months. And during that moment, each time that a new system is installed inside of the building, we will try to connect it to the platform itself, okay, to really optimize the communication and start working with those data. Starting learning also a little bit more about the building, so we can already compare a little bit the actual situation against what will come later from our system. And then after the retrofit apply, then the toolkit itself is operational, and we will start to monitor how is now the building behave, or behave the building now. So we get some energy dashboard, we get some application for the dwelling, but also we have some academic review of the model to see if what we plan for the building is really the one that we will get after, and so we can refine our analytics to be sure that we really follow the different things that we expect at the beginning. So the cloud platform, and I don't want to be too technical because I know that IT is not something very convenient for a lot of people. There are really two parts in the cloud platform. So we are talking about the building system itself that Claudio Del Perro already introduced. And the building system is the part that is installed inside of the building. So the building system is mainly all the different hardware and devices that has been installed. So I mean the fan coils, the MIMO, the heat pumps, the solar panels, that we are really connected and that's able to communicate through, between themselves, but also to the gateway or directly to the cloud platform using internet connection. Mm-hmm. The gateway is there to control what is going on inside of the different device, also to reflect the different change that is coming from the building, and to be sure that we have a way to monitor the behavior of the building inside of the building and not only on the cloud platform. The reason why we want that is to be sure that if there is any problem in communication in the future, we want to be sure that the technician is able to look at the data inside of the building and really able to fine-tune the setup without having to go in the cloud immediately, because maybe it's in the basement, maybe it's in some place that he could not access internet on that moment. So he has all the system to monitor what's going on already inside for a certain delay. We have also inside of the building system different mechanisms for security. The first one being the fact that there is no communication from the internet to the building itself. All the communication is always done from the building to the external, so that allows us to close any firewall and any way to interact or to go out from an hacker to come inside of the building. So it's always a communication from the building to the external. The same way, to be sure that we can make some adaptation and we can fix some security issue that could occur inside of all this infrastructure, we have built in a system to update the different components. Okay? That we know that for the moment, even if there are some leaks that is not known today, in 5 years, 10 years, There could be some new discoveries in terms of security, so it's very important that we are capable of updating the full system inside. So the building system is now working totally inside of the building, and at regular interval, it will start sending the data, telemetry data, to the cloud platform. So for each of those devices, we are selecting some of the different parameters, and we send them to the platform itself. So this is for the building. And then on the other side, we have everything which is installed on the cloud. So that means a set of different applications, the first one being authentication, and then all the different systems that we need. So it's been a little bit too fast. So the building system allows you to collect the data from the different devices. It transmits the data securely because it's encrypted to the web portal. It also forward the control command to the device when there is something. It allows you to maintain the system, and it stores the data locally, like I said. The web portal itself is composed by different modules. The first one being the authentication. So any action, any interaction with the cloud platform is fully secure under authentication. Even the device that is installed inside of the building, when you try to communicate, is authenticated inside of the platform itself. So we allow to manage a different user. We manage the privacy of the user to be sure that there is no information that is not needed inside of the platform, and that we stay at all the different parameters and regulation about GDPR and others. And we manage also the authorization, so who has access to which data, which tenant has access to which fine calls, or who is, how do we manage the fact that the owner has access to the MIMO and global hardware inside of the building itself. Then we have a second component, which is the DSS micro application. So the DSS is the decision support system. It's the one where we create that view of the building that I told before. So where we filled in all those information about the number of floors, about the energy consumption. It's really an application inside of the platform, which we call the decision support system. Okay. So the DSS will collect all those information and support the owner in this decision for that. Then we have the data collection itself from the telemetry. We have all information about all the application for the BEMS, Building Energy Management System, allowing you to see dashboard and to look at the data immediately from your device. Then the global information administration application, that's the one who allow you to create your project, manage a project, invite new tenants inside of the application to allow them to see the fine call from their dwelling, or also to manage the fact that the tenant might be changed during the lifetime of the building itself. Is in the administration part. Then the update of for the building. And the two last part is the different way for the university and research center to analyze the data and optimize the different models that we have in the platform itself. And for that, we store the different data anonymously inside of our database. Mm-hmm. So, and thanks to the GDPR, all the data about the tenant and the user are fully separated from the data that we have about the building itself. So there is no correlation that is possible because we are managing that in different systems. And it's only thanks to this authentication system that we have first above that we can make the user interact with it. So, small views of the cloud platform. So the first one is a screenshot of the administration portal. What we can see here on the screen, okay, let's make it work, is that, so basically, it doesn't, no, cannot see it. So we have the first top menu where we have the name of the platform. We have also some the menu on the left which is there. It allows you to scroll against the different part. Then in that case, it's the view of the different techniques and machine device that we have inside. So in that case, it's a test building. We can see that we have one fine coils currently on. We have 2 heat pumps that is connected there. So it allows you to see what it's installed inside of the building. Another view is also in the administration portal. It's about how do we grant access to people to a specific building inside of the system. So here we can see that the apartment 6502 on the floor 1, we have some people, 3 people who have an access to the information about that building. So it's always possible to create new access, and also a tenant can invite other people inside of the application also. You can imagine that you are the tenant and you want to invite your wife or your kids. You can send an invitation and then it will be accessible from that screen. Another view about the tenant application. So the tenant application is a responsive design application that can run on the devices. So the first thing that when you get inside of the application is the login and password, because there is no way to register from the application. You have to be invited by the facility manager or the owner of the building to be able to look at the information. After we have a consent page, GDPR, that we need to do. Some information about who has access to the specific building. So here we see that for the apartment B105, the main contact is this person. This is his phone number and information. Why do we need the phone number? It's because we are sending notification to that person to be sure for 2-factor authentication. At the moment when he log in, we need to be sure that it's the person who has access to the building. And from here, we can also immediately change or invite someone else. So we have a main contact, and then we have subcontact that is there. There is no way for the main contact to unregister himself. It's always a facility manager who is in charge of that. Back. So then the tenant application lists the different rooms that he has in the dwelling. So we could see the rooms correspond for us to a fine coil. So in fact, we are only listing the rooms where there is a device inside. There is no other information about the dwelling itself. So he listed the different fine coils. And then when he selects one of the fine coils, he can look at the current temperature, and he can change the temperature itself for the desired temperature that you want for the dwelling. And we have also a custom information that is done there, which gives you an overview about the kilowatt hour that is saved or compared to what we had before, or that could be translated in an order. So this second information is purely custom, and we can change it on demand of the facility manager. Then we can come to the analytic application itself. So analytic application allow the universities and research centers to look at the data in a very fine way. So we can select one building. So I say first column is selecting the building, the second one is selecting one device for that, and the third one is all the data source that we have for that device. So that means the temperature, the speed of the pump, also the kilowatt produced by the solar panel. So for each device we have a set of data sources that is coming inside of the platform. And then we can make some aggregation, we can make some cleaning of those data to really produce a normalized data set, time series and data set to allow us to work on the data. And so by selecting, in that case, one of the parameters data source that we get a graph about the last period of time, and we get also some information about the observation that is done by default. Okay. Based on that, the universities and people who will work on the model and enhance the model along the time can extract that information and work locally to complete the model and provide new formulas and new calculation that we will then re-implement inside of the platform. About the DSS, so the DSS is the decision support system, like I said before. It's a set of screens. It's about 125 fields that you have to fill in to know the building. And this, we have several screens where you have all those fields that allow you to describe. So in that case, it's the first screen, so number of floors, number of 8 of each of the floor, also the total surface of the roof, total surface of the facade on the north, south. So it's really a list of all the different information that we need to create that model and propose new information, propose some retrofit option for the owner. Okay. So when you see that, after you get information about the different choice, and so inside of those choice, you can scroll for the different one that you get. And at a certain time, you can click on select if the one that you want to have. Okay, we'll see after. There is also other view for graphic views, but this is the one way to compare. Then we can select one of three of them, and based on those three, make a different analysis. So the view that you have seen on the card is out of that list. So we can see that for one calculation of the building, after the DSS, we have about 3,000 entries. And those entries will represent all the different cases that we will analyze. And represent the number of PV installed. You can see that it can vary, the number of MIMO that is necessary, the number of heat pumps. So it's really all the 3,000 different cases in that, that is possible for the retrofit, where you need to select which one fits the best for you. Or maybe which is the most common, so the less expensive, the more environmental friendly, or the more linked to your budget. And then we get also some graphs that allow you to compare the different options using the yearly CO2 emissions against the expended global cost, or several entry points that allow you to create the graph and try to find out the best approach for you inside of the application. There's still some time. Yeah, so just to show that it's a little bit technical, sorry. This is the view of the cloud platform itself and of the system. So we can see that we have, laser is not working, so we have a lot of different parts of that application itself. And the main point is really the public website where we get in. And from the public website, you can switch to the cloud platform itself. Okay. And every action is always done by this application in front, where you get against our firewall to protect the full information. And then after that, we have the different deployment and web application that we have seen before, the DSS, the BEMS and others. Then we have done everything about the deployment tools for the mobile, communication for the mobile and notification for the mobile. And then we have above all the image repositories that allow us to do the over-the-air update of the device. On the back of the system, we find the different database, but also all the authentication system. We choose two-factor authentication, so that is one of the highest level that we can have now on the internet. With the validation of the user. And finally, inside of the building itself, we have also a set of components that is running there. So you can see in yellow on the top the different kind of hardware that we are using. So the fan coil, the in-pop MIMO, and the hot water system. All of them are communicating directly with the gateway that you can see in the middle. We have a virtual representation for each of the different physical hardware. And so we are maintaining that view in the middle. Then we have the database and all the access that we can do, and over-the-air update for the application. That's it. Do you have any questions?
Okay, and now I would like to present our two case studies. The first one is the Italian one, is in Bagnolo. It is characterized it was characterized by low energy performance. It was equipped with gas boiler, while no cooling system was installed in the building before the retrofit. We applied our toolkit to this building. So first of all, we installed the envelope without the use of scaffolding. So just with the movable platform, we installed all the envelope in the building. Of course, also the windows has been retrofitted by using, through the substitution of the glazing only, because the frame was characterized by fine quality. We retrofitted also the gasket around the frame of the windows, and also we added an insulation in the shutter box of the windows that generally is a point of thermal bridge. About the technical plant in the building, in our Italian case studies, we installed two heat pump with two external units that has been designed in order to reduce the noise. As already said also by Claudio, we installed 3,000 liters of storage tank that has been filled with PCM material in order to increase the thermal capacity of the storage. In the right side, you can see all the hydronic and electrical distribution inside of and also outside of the building. It is interesting to notice that the electrical connection has been made in between the old facade and the new one. And then we installed also 10 kilowatt peak of photovoltaic system with this kind of special PV tiles that has been developed in order to perfectly integrate it in a roof tile like this one in the case studies. The PV tiles are easy to handle by few workers, so it is very easy also to install and to speed up the installation process too. Let's move to the inside of the building, where different IoT devices, probes, and sensors have been installed. The radiators also have been replaced with the new smart fan coil, able to provide both heating and cooling. This is the final layout of the building, as it look like, very similar to the building nearby. Then let's move to the French case studies in Lyon. It is a multi-story building. Also, this one was characterized by poor energy efficiency before the retrofit. We adopted the same, almost the same component in order to retrofit it. The windows in this case was totally replaced due to the poor quality of the previous one. Also, a shading system here has been installed in order to control the solar gain and to avoid the glare problems. The external unit in this building has been placed on the top roof in the new glazed component that has been installed. Here you can see some hydronic and electrical connection that has been made also in the gap in between the existing wall and the new facade. Here, 15 kilowatt peak of photovoltaic tiles has been installed, and this energy is almost able to cover almost the overall demand of the new technical system. This is the final layout of the building as it looks like, and now I would like to leave the floor to Alice that will introduce the post-occupancy evaluation. Thank you.
Thank you very much, Fabrizio. I think for a moment what we would like to do now is to leave the more technical aspect related to the pilot projects, but look at the way the project development was perceived by the people involved, and namely the residents, but also the people working on the ground to make it happen. And I see this as a strong part of our work and our involvement in the project as Housing Europe. So this is something that we've been working on from the start of the project. But today we look more specifically at the evaluation towards the end of the project and what lessons we can draw and learn from it. So if we look at the results of interviews that we had with the social housing companies, the construction companies, and the stakeholders involved on the ground, they have really all highlighted how they really believe that the added value of the HART project is in the exceptionally high expected energy savings that can result from the project. And this is also very important because it can definitely contribute to reducing energy poverty. So you have to keep in mind, we're talking about social housing neighborhoods here, and most of the people living in the buildings that you've seen are living with relatively low incomes. Some of them already in the past spent more for their energy bills, more than what they have to spend on the rents. So this is really something which can make a huge difference. Especially in the current context, we see high rates of inflation all around Europe, and more than a third of this increase in inflation is actually due to increasing energy costs. So this can really make a big difference. The second point that was highly appreciated was the fact that this project represented an experimentation, and it was also a way to learn how to cooperate between the different sectors. So social housing companies, but also universities, the industries involved, and also that there was a way for this cooperation to take on board the residents' needs and what they had to explain about the impact on their daily life of the technologies implemented. So here I just added a quote, and it's actually from the president of Acer, the company that manages the Bagnolo pilot that you've heard about, that energy efficiency is per se a very important topic, but for a renovation project to be successful, it has to enhance the satisfaction of residents and basically really respond to the needs of people. And this is also an important learning from a policy point of view, I would say. There were, of course, some first, a third point, also very important, for the housing providers involved in the project, but also the, let's say, the broader social housing community. So the experimentation is very important, but of course our ultimate goal is to reach a wide-scale retrofit. We're all aware of the context. The renovation wave means doubling the efforts to renovate the existing housing stock. And of course, this is something that will represent a huge effort for the sector. So the market uptake of the HART toolkit and the way this can make the process more efficient and less costly will have also a strong importance here. There were, of course, some issues or some downfalls during the project implementation. First of all, we heard the comment from both pilots that working on innovative projects means that one has to sort of expect the unexpected. So, and this is an important learning from other similarly innovative projects, to budget in a potential increase in cost in duration of the project from the start. Also, there were some interesting points and some learning to do about basically dealing with different systems, for instance, when it comes to insurance of construction products in the different countries. And it's quite a technical point, but I think it resonates with what we heard from Housing Europe members, that an increased effort towards standardization and harmonizing standards and regulations in construction and renovation can really help dealing with some of these obstacles. Last but not least, of course, we saw that the project was heavily affected by exceptional conditions of COVID-19 pandemic. But in this sense, it was also an experience to learn how to navigate through this kind of crisis. And what we see today is that when it comes to, for example, availability and cost of materials and building components, the crisis is definitely not over yet. So this is also something important to keep in mind and to have to learn to work with. So if we look more specifically at the points that were raised by residents themselves in a series of interviews, of course, when we carried out the interviews, it was a bit too early for them to really grasp the full impact of the renovation work on their quality of life, but some of them already could see an increase in comfort and increase in heating comfort only from having better insulation. So once the project is fully implemented, of course the potential is there to really have a strong positive impact. Also, the residents' feedback on their experience of the renovation work and of the tools installed is really key for acceptance, but it's also very helpful for the partners involved in the project themselves, because they had to adjust the products based on the feedback. And this is something important to learn, to consider residents as experts themselves in the way they use and they live in their own home. Also very important, and this was unfortunately maybe the most problematic issue, was that having a clear timeline from the start and avoiding delays can really be a key factor for residents' satisfaction. Because they are ultimately the ones facing the inconvenience of the ongoing work in projects like this one, where we're actually renovating buildings with people living in them without moving them out. So they experienced problems with some of the temporary solutions that had to be put in place. Even more, they were concerned about not knowing precisely, will I have heating installed before the winter, will I have air conditioning for the summer? So the insecurity can play a negative role. But also interesting, none of them actually was particularly pointing at problems with having works in their homes, in their flat. And this goes to show that having a dedicated team in place, a constant contact point and a constant exchange with the social housing companies and the companies involved, and this process of building trust and communication can really help solving problems and go beyond the temporary problems. Sorry, I think I skipped the last. Wow. Another point that we wanted to look at was to try to think of the driver, so what matters to people in a renovation process. So first of all, there's of course the aspect linked to increase in comfort and also potential reduction of energy bills, which play a strong motivating role. And most of the people interviewed still thought that on the long term the project will have clear benefits, strong benefits for them. But they don't have clear or precise expectations of what this could mean, for instance, in terms of the bills that they get at the end of the month. Will it be reduced by how much? So, and this they blame the lack of technical knowledge to be able to explain that. Some of the residents were also concerned that the fact they won't have control on their energy use, so that the system kind of optimizes itself could be problematic, but again, there's no clear feedback on this. But this is why it's also important that the social housing companies involved are already planning future meetings with the residents and to come up with guides and information material to really help them having a best possible experience in their renovated homes. Last point, which I found very interesting, is that another motivation for the residents seems to be still the ecological concerns. And this is something that we noticed already at the beginning of the project through a survey that we did. But I think in the most recent interviews, this is even clearer. I think that people really start to connect what they see on the news every day, the droughts, the problems linked to climate change. And here I just want to quote what one of the residents, a lady in the Italian pilot, said, that if our building can consume less energy and use more solar energy, that is a natural resource that doesn't negatively impact the climate, it's a way that our building can help the planet. And it's better and more important that everybody does his part, even if it's very small. And with this, I finish.
In the second session called Pathway to Decarbonization, we'll be looking at three different presentations. The first presentation is the monitored data from our Italian demo case, which will be presented by Aaron from URAC. The second presentation is will be from Philippe Mosley from European Commission, DG Grow. He'll be showing that how this renovation wave is an opportunity for all stakeholders. And then João from Housing Europe will be presenting Shape EU, which is a project that just started, and it is looking at the district level for the just energy transition, and he'll be presenting that project. And then we have Shosha from Housing Europe, who will be giving the opening remarks for this session. Please.
Thank you very much, Sudhanshu. Indeed, this session is really going to bring some different perspectives together to look more closely at what is really an existential challenge that we are all facing now, and that is really what is indeed the best path to decarbonisation. And my job is to just introduce it from the perspective, of course, of Housing Europe. And I think, as you all now know at this stage, Housing Europe is bringing together the types of organisations you've seen earlier on, and the types of public housing providers, but also social housing providers, limited profit and cooperative housing providers all over Europe. So our job at Housing Europe is to help define the carbonisation pathway for that sector, but we are really in the middle between the EU policy making and between the really stark reality on the ground. So we are trying to link up those two sides of the puzzle in a way. So just a quick reminder, this is Didrik Samson, so the head of cabinet of course the commissioner really leading the work on the Green Deal, Commissioner Timmermans. And just a reminder just how big this challenge is. So the biggest environmental project the world has ever embarked on, and which will set first Europe and then the world on a course to a sustainable future. And a big commitment, so to decarbonise the entire continent, of course. So housing is not, although for us housing is really at the heart, at the centre of this, of course we have to work across sectors. And then to add to this challenge that we have came along an even more urgent challenge, and that is the one referred to there by Kadri Simpson, so the Commissioner responsible for our energy strategy. And that, of course, is this new and even more urgent reality resulting from the, as she says, the ripple effects of the Russian aggression to Ukraine will cause every aspect of our energy system to change. And so on top of the legislation that came with the Green Deal, we also have this Repower EU initiative that was introduced as a way to introduce the policies that are needed to achieve this shift. So where does that leave, indeed, the type of housing providers that you've seen a glimpse of their work this morning? You've seen the implementation of the retrofit kits on the ground. You've heard also from Alice Pettini talking about the evaluation and the perspective of the residents actually living in those homes. So indeed, it's to bring these levels together. Living in those homes with limited income, often a diverging quality of those existing buildings requiring quite different interventions, diverging climates, of course, and the different approaches that those different contexts actually require. So we are in the centre. Housing Europe is linking those, and HEART is fitting in, I must say, very well into this picture, because these types of initiatives, particularly with the new challenge that Repower EU has set us, and that is an even faster rollout of renewable energy and an upping of the renewable energy targets that were originally set. We see HEART extremely well placed, because heat pumps and solar PV are actually two of the main tools that have been identified as required to make this increase in the proportion of renewables we're using in the building sector. So these are the types. So these are the very high-level political initiatives that are indeed pushing and shaping this agenda. And what are they turned into? They're turned into a whole raft of different legislation being produced by European institutions. And there I've just a little taste of those. So there's the Energy Efficiency Directive, which is cross-sectoral, looking at how each sector, and building being one of the major ones, how they can reach the targets set in the Paris goals. Then the Energy Performance of Building Directive, obviously more specific, zoning in to our field here, that what we are talking about. And there, just we can see very ambitious targets, up to 350 million units to be renovated, and with the EPBD providing that guiding regulatory framework by 2030. The RED, so the Renewable Energy Directive, again, very relevant for the work being done by HEART and very relevant for our sector. Then, of course, how to finance it. I've mentioned there the ETS, so the emissions trading scheme. So there are plans being discussed at European level to extend emissions trading systems to buildings, so which would essentially introduce a tax on inefficient, dirty fuels being used to heat and cool our homes. So that's being discussed at the moment, quite controversial, of course, because we could potentially be taxing people who have no agency or no power to change those heating systems. So a very tricky piece of legislation, as you may have seen in the news. And of course, the Repower EU, so this initiative to boost and accelerate the rollout of renewable energy. Then, who are we? So we have this legislation, and then our job at Housing Europe within projects like HEART, and when we are negotiating and discussing with the European Parliament, with the European Commission on what type of legislation should shape this process, we are representing, again, those types of public housing organisations, often housing low and middle income groups, often using public budgets, but not only, but working within quite a limited budget to deliver their goals. So they roughly, in a rough estimate from our observatory, they are renovating around 200,000 per year, and also keep in mind new construction, so delivering new homes about 200,000 per year. And they've estimated, and I must admit, these figures were they estimate that they, by 2030, could renovate 4 million. But I think in the current reality, this goal needs to be revisited. And this is what I will quickly look at now. So the changing reality for these organisations. Because obviously their goal is to continue to deliver affordable homes, and make sure they're available, so meeting the housing demand. Obviously, there's a large shortage of housing, particularly in our urban areas in Europe, and to make that sustainable. And their job is to balance those three objectives at local level. Quite a challenge in the current reality, as many of you must know. So a bit of the reality, indeed, is that we have referred earlier on to the inflation really impacting households in Europe, particularly those who live in inefficient homes, those who are relying on petrol-based travel, so who use a car to go to work, for instance. But that's the impact on the larger population, which is one which, as a society, I think will become one even more urgent to deal with when we go into the winter coming up now, with predicted rises of up to 30% on people's fuel prices. However, in our sector, we can see even more extreme examples of rises in prices when it comes to construction materials. So it's putting an extra, let's say, an extra level of complication on to our mission to renovate those 4 million units by 2030. So there are many measures in some member states being brought in to help to try to address this serious bottleneck at the moment, but we must say that a lot of the targets probably will need to be revised. So that is really a reality, and we saw it also in the rollout of HEART at local level. So delays when it comes to delivery of materials, rises in prices of those materials. So while we are determined to keep the show on the road, to keep activities up, because now more than ever we need efficient buildings and we need to use renewables. However, the supply chain realities do have to be taken into account and do require new policies to address those. There we see just a quick reminder of the potential. So of the potential of the sector. So very often we see that actually in the built environment, the social housing sector is actually more committed to sustainability and to implementing energy efficiency programs than the rest of the private actors. But there you see also to what extent they are more representative of the building sector in different member states. So that's just an indication that we have, let's say, more potential to roll out the type of HEART schemes in some member states than in others. And here I will just finish up by indeed reminding that when we are devising decarbonisation roadmaps in our sector, of course we are looking for the solutions, innovation in the solutions adapted to individual buildings. However, by its nature, the sector is also looking beyond the four walls of the individual blocks or individual homes to look at what is the potential optimization of that strategy at the neighbourhood level. And my colleague João will go into more details about that a little bit later on. And of course, what is also crucial and at the heart of our work is that, of course, we have to decarbonise. We need optimal, efficient systems within the buildings, within the homes. But if at the same time we can make those districts better places to live, then we have to take this opportunity and use the renovation wave as also a wave for quality of life for all in Europe. And that's it from my part for setting the scene. So I give you back the floor to introduce the speakers. Thank you very much.
Next we have Aaron from Iraq. Aaron will be presenting the data, monitoring data we have collected so far from our Italian demo case.
So, good afternoon, everyone. My name is Aaron Estrada, and with my colleagues Pietro Zambelli and Costa Zompas, we try to analyze the data from the monitoring systems, and not just for the sake of see what's happening there, but also to compare if the results after the refurbishment actions were, the impacts of the refurbishment actions. So in this case, we have two demo cases. The first one is the French demo case, which is in Lyon. The available data that we have is the indoor conditions. So we have the temperature, the relative humidity, the CO2 concentrations, and also some energy consumptions. The time frame for this data is from September 2019 to April 2021. And with this data, we were able to do some analysis like the average and distributions of the indoor conditions, also to calculate the predicted mean vote and predicted percentage of dissatisfied, which are two indices that indicate the thermal satisfaction inside the apartment, and also some analysis about the energy consumption. The only limitation here is that we couldn't do some analysis for after the refurbishments, because at that time the refurbishments were still an ongoing process. These are the blueprints of the Lyon apartments, in which in 2 floors there are distributed, monitored 7 apartments, if I'm correct. And here we can see the temperature distribution among the monitor data. So we can see some fluctuations of the temperature that goes from 20 to 25. And in the summer period, we also have temperatures that are reaching also 30 degrees. These are the temperature distributions that goes from 40% to 80% actually. And as well, we have also relative humidity values for each of the apartments that can vary. It depends on the apartment, because these are some metrics that change based on the behavior of the tenants. As well, we have the CO2 concentrations here. We can see that they can vary as well from 2,000, 3,000 ppm. Especially in the winter period, and if we go to the summer period, we can see that this decrease a bit. As well, these type of metrics are usually dependent on the number of integrants inside the apartment, so this might change depending on the size of the family, the size of the apartment, and so on, and how also they ventilate or change the air, or if they open or close the windows, and so on. Then we also have the predicted mean vote, which is an index that indicates the thermal sensation inside the apartment. So this can vary from +3, which is hot, or -3, that it's really cold. We can see here that during the cooling period and heating periods, they are more or less distributed in a neutral predicted mean vote, which indicates that inside the apartments, people might be feeling, they don't feel like a warm weather or a cold weather. This other index is called the predicted percentage of dissatisfied, and in this case, this measures the level or the percentage of dissatisfaction inside of the apartments. As well, here we have like percentages that can go from 5 to 30% of dissatisfaction. But this will depend also on people, because at the end, these are just quantitative measures of the dissatisfaction in this case, but this will depend especially on the people and how they feel actually. These are more information about the PMV and the PPD values in the cooling period. So we can see
that in some cases, the darker, for instance, the PPD is, it's because it can feel more dissatisfied, let's say. Yeah, this is during the heating period, so yeah, in this case, people might feel that it's cold inside the apartments. And finally, we have some energy consumption about the global electricity. This also depends on how people behave inside the apartments. And we can see some peaks at the end of the April 2021. Yeah, it could be good to see what's happening here. And also some consumptions, yeah, the cumulative electricity consumption for the whole apartments. So we can also see here that in some cases the tenants behave better than the others. Yeah, this is all behavioral at the end. About the Italian case, we have available data about the indoor conditions. So in this case, we have the temperature and the relative humidity. We also have energy consumption for the air conditioning and the boiler before the refurbishment. And we have data from September 2018 to April 2021. We have to take into consideration that the windows were installed by September 2019 and the insulation panels were installed in December 2020. And with this data, we are able to analyze the average and the distributions before and after the windows installation for the temperature and relative humidity, also the predicted mean vote and the predicted percentage of dissatisfied before and after the window installation, and the energy consumption about the air conditioning and the boiler, yeah, in a monthly basis. The only limitation here is that we couldn't do more analysis after the insulation panel installation because, yeah, there's only few data available. Yeah, as we saw in the previous session where, yeah, this is the Bagnolo in Piano building. This is a blueprint of one of the floors of the building. We can see here the indoor temperature in Bagnolo in Piano before and after the installation of the windows and the insulation panels. As we will see before, we can see that the temperature values are more stable. And as you can see also, there are no more data after the insulation panel, so we cannot see if there is an impact in the insulation panel. And here we have the distribution of the indoor temperature before and after the window installation. We can see in the before and the left, we can see that yeah, the temperatures are distributed are not that normal, let's say. So they can vary from 15 to 25 or even 30 degrees. After the window installation, we can see that the data that we have, it presents a more normal distribution, so it's more compact in a way that it changed how the temperatures are inside the apartments. And now it doesn't vary that much, so it stays more in the values from 18, 20 to 25. This is the relative humidity values. It's the same thing before and after the windows installation and insulation panels. We cannot see, this will depend also, as I said before, from the behavior of the tenants. So, but we can also see here that it changed a bit. Before and after the window installation, we can see a distribution that goes from the 30 and the 60 and 70% of humidity. And after the window installation, we can see a more compact, let's say, or at least we can see that the relative humidity values are more condensed in between the 50 and 60. We also calculated the PMV and the PPV during the heating period, so we can see before that the people could feel dissatisfied inside the apartments because, because the temperatures might reach cold temperatures. After the window installation, we can also see that this changed a bit in the sense that the dissatisfaction decreases. So this means that inside the apartments, you can feel better, of course. Yeah, this is the same data for the rest of the apartments. And finally, we have the energy consumption for the air conditioning. So we have data for 4 apartments before and after the Windows installation. Here we have to see better if the data, because we can see that there is some increase in the consumption of the air conditioning. But we are not sure if this is because the summer period in 2020 was hotter than the previous year. So, and also because this also depends on how people behave inside. And we don't know for sure if, for instance, there are new tenants coming to the apartments or not. So this is something that we would like to go deeper. About the boiler, this is again the energy consumption for the boiler. We can also see here that in 2020 there is some increment in the consumption of the boiler, especially in one of the apartments. Some final conclusions. So, for the French case study, we only saw that we were able to do some analysis on the available data. So there were no impacts presentation here, but it will be really necessary to see or to have more data to evaluate these impacts. And for the Bagnoli in Piano case study, we could see from the qualitative point of view that the indoor conditions were improved after the Windows installation. And also it will be necessary to see more data to see what were the impacts of the insulation panels. Thank you very much. And if afterwards we have questions, With them, sorry, could you repeat again? You mentioned the impact of behavior. Yes. Changes the results. Yes. So I believe that we need to take into consideration not only, not focusing only on changing from the technical point of view, we also need to target people in a way that we can make them understand how the behavior affects the in this case the consumption, the indoor conditions and everything. So it's really necessary to focus not only on the technical point of view, but also to focus on to see how to change the behavior of people. So this is. But with this data, unfortunately, it's not really possible to see, this is only a quantitative analysis, so it might be necessary to do some more qualitative data.
Is there any more questions? Thank you, Aaron.
Thank you.
For the next presentation, I'd like to invite Philip Mosley from DG Grow. He'll be presenting on how this renovation wave is an opportunity for all.
Hello, everybody. Good afternoon. Nice to be here in person. And hello to everybody online as well. So I'm working in DG Grow, which is the Directorate General for the Single Market, Industry, Entrepreneurship and SMEs in the European Commission. And I'm working in the construction unit there, where I'm responsible for policies to do with sustainable construction. So that's what we're now calling the green transition. and that is not only energy and energy efficiency of buildings, but also the circular economy and resource efficiency aspects of construction and the whole life cycle of greenhouse gas emissions. Now, the renovation wave, I mean, the strategy was already out now for a while, and I guess you all are aware of the main lines of that, to at least double the annual rate of renovation, which remains far too low. The daunting kind of scale of what we're talking about here, over 220 million building units in Europe were built before 2001, which suggests that most of those are going to need renovating. There are these kind of eye-popping figures of money that's needed to be spent on renovation. The figure in the renovation wave is 275 billion a year, although of course a lot has happened since the renovation wave came out with the COVID and the war in Ukraine and so on, and the prices, but enough to say that it's a huge amount of money that we need to be spending. And also the calculation in the renovation wave that the Commission did on the additional number of jobs for construction. Again, this is, will probably have fluctuated by now, but suffice to say it's an enormous opportunity for the construction industry. Tens of thousands or hundreds of thousands of additional jobs can be created by renovation. So there's a figure in there in the renovation wave of 12 to 18 local jobs per million euros. And of course, construction is a particularly local kind of enterprise. It's an enormous business opportunity for construction, as well as all the energy and climate benefits. When we talk about construction and the construction sector, we're using this term ecosystem in DG GROW that's coming from the European Industrial Strategy. Construction is one of 14 industrial ecosystems in the strategy, and the ecosystem is basically a broader look at all the actors who are influential in construction beyond just the industry itself. The ecosystem has a gross value added of almost 10%, and over 25 million jobs in over 5 million firms. So it's really a major economic player in Europe. And at the same time, we know that not only do buildings consume energy, but also the act of constructing and renovating generates waste. And in fact, construction and demolition is the single biggest source of waste in the EU, with over a third. And it also is responsible for half of all resources extracted. So the environmental impact of renovation and construction is huge, which is why this is addressed in the renovation wave as well. Now, the renovation wave had or has a whole action plan with it. So it's not just a strategy document. It has a series of dozens of different specific actions which the Commission has been implementing. And on the screen here, I've got some of the ones that we in DG GROW are particularly closely involved with. So on the left side, you see the ones which are more digitally focused, because we want construction to undergo a digital transition. So we're looking at the introduction of building renovation passports, and this is of course something that is in the Energy Performance of Buildings Directive. But not only renovation passports, also we are working on this concept of a digital building logbook. And this would be a single repository of all the data for a building. So not only the renovation passport and the energy performance certificate and maybe the consumption data, but also things like the permits, the urban planning permissions, and kind of legal and administrative data like that, and also, of course, the plans or the BIM model for the building itself. So all of this would come together, and we've been developing a framework for this digital logbook. Then also at the same time trying to digitalize the permit system to accelerate the granting of permits, because this is one of the ways we can accelerate the rate of renovation, of course, is by making sure that we don't anymore have paper-based systems in permitting. And then the use of building information modeling to get better collaboration between the design and construction teams. And this also leads to higher quality buildings, which is one of the things you need for high energy performance. And then on the right side, we have some of the measures in the renovation wave, the actions which are dealing with the environmental side. So this whole life cycle approach now, which we're increasingly looking at in the Commission, not only looking at energy efficiency or renewables alone, but the whole life cycle impact of buildings. So that's from the construction through the operational lifetime and the energy efficiency of that, and then the end of life, which is the demolition and the reuse and recycling at the end. So we're also looking at the possibility of reviewing material recovery targets. This would be under the Waste Framework Directive. And then looking at procurement as a really powerful tool for public authorities in particular to demand higher standards of sustainable construction when it comes to renovation. And this is something where cities and regions can really take action with procurement. When it comes to the whole life cycle of greenhouse gas emissions, we have the Levels Framework for Sustainable Buildings, which really started this whole conversation at an EU level. It has 16 indicators for the environmental performance of buildings, energy consumption being one of them, of course. But another one is the global warming potential, the whole life cycle impact. Then we're working at the moment on a roadmap for the whole life cycle emissions of buildings coming out of the renovation wave. We're aiming to get that completed during 2023. And then under these revisions of the energy directives and also of the construction products regulation, these are all ongoing revisions now, all of these are addressing in some way this whole life cycle question. So in the EPBD, there's a Commission proposal at the moment that all new buildings would need to calculate and disclose their life cycle CO2 or global warming potential. Then in the Energy Efficiency Directive, there's something on life cycle in the article on public procurement, and also on the article for the 3% annual renovation rate for public buildings. And then this data that you need in order to calculate a building's life cycle analysis would come from the products used in the building, so the individual construction products, and these would be coming from the regulation that is under revision as well. So the construction products regulation, it's colleagues in my unit in DG GROW who are responsible for this, and that is a whole revision in itself, which is undergoing revision right now. The Commission proposal was out in March. I think for the HEART project and for you, probably the most interesting aspect is this sustainability requirements that would come in for the first time for construction products. So potentially we would have mandatory carbon footprint information for all construction products. So this is from everything from windows to cladding panels, roofing, insulation. All of these products would need that data that enables a life cycle calculation. And also then potentially also you'd have carbon footprint data for things like energy consuming appliances that go in buildings, like boilers and these kind of things, and PV panels. And then of course all of this is very nice, and then COVID came along, and also we have the war in Ukraine, which is extremely unhelpful in many ways. And the result of both of these has been this enormous rise in prices that we've seen recently for everything from energy, but also for construction products and construction materials, and we've had delays and all of this. So this is just a kind of reminder that we have all these very nicely laid plans, and then a kind of disruptor comes along in the form of a virus and a war, and we have to take another look at all of these things. It's not going to throw us off course though. I think this was the reason why the Repower EU initiative was adopted, in order to move away from fossil fuels and specifically Russian gas and oil. So from an energy consumption and energy efficiency point of view, where there's even more reason now to be implementing the kinds of innovations in the HART project, and accelerating the renovation rate even than before, because of this urgency now to get off the Russian fossil fuels. So what's in the Repower EU in practice is a higher proposed energy efficiency target even than is in the Energy Efficiency Directive recast proposal. So going from 9 to 13% by higher than the baseline. A higher renewables target for the Renewable Energy Directive, going up to 45% renewables. And then there's these interesting things for buildings, the solar rooftop initiative, which would make it mandatory to have solar power on buildings, or solar energy panels on buildings. And then specific measures in Repower EU for heat pumps. So looking at doubling deployment in the next 5 years, looking at these quite large numbers of heat pumps, which are one of the most effective ways to decarbonize. And one thing we're particularly keen to do now is to ensure that the heat pumps and the solar panels that are going to be rolled out across Europe are manufactured in the EU, and to the extent possible. And then also this acceleration of permitting. So not only the digitalization aspect that I mentioned, but trying to make it easier so that member states would define what they're calling here renewables go-to areas, areas where it's accepted that renewables could be fast-tracked through the permit process. So these are some of the interesting things in Repower EU. Then we have, in DG GROW, we have a lot of work ongoing on the skills needed for not only for the energy transition, but for construction as a whole. There is this Pact for Skills, which is a Commission initiative across all industrial ecosystems. But under that, there was a specific skills partnership for construction that was unveiled in February by some of the major European associations for construction, and they pledged to upskill and reskill a quarter of the workforce in the next 5 years, which is really a great thing, and it mentions specifically skills on energy efficiency, circular economy, and digitalization as the needs there. What we're doing now in DG GROW to bring all of this together for construction is we're creating this document called the Transition Pathway, which we're going to be finalizing towards the end of this year and perhaps early next year as well. We've been holding a number of consultations on this through the High-Level Construction Forum, which is the main forum we have to have dialogue with the industry and also with member state governments. And we had a staff working document that came out at the end of last year that proposed scenarios by 2030 for the transition of construction. And we've had a lot of consultation responses back. We're going ahead with drafting the final version of the transition pathway now that will include some ideas for new action looking forward to the future. So that's one to look out for. Another big policy area that's relevant for sustainable buildings is the EU taxonomy for sustainable activities. And this is the initiative that is trying to have harmonized EU definitions of sustainable projects from an investment point of view. We already have published the criteria for climate change, adaptation and mitigation. And under development now, we have new criteria on what would be sustainable from the point of view of water, biodiversity, pollution, and circular economy. And that includes some aspects related to buildings and construction. So this would really channel the big financial institutions' money, things like bonds and pension funds, into a harmonized EU definition of green investment. I can just highlight the funding programs that are maybe interesting from a point of view of sustainable building, so energy and resource efficiency and circularity. In Horizon Europe, so this is the research and innovation program, successor to Horizon 2020. These areas are really the most relevant probably for buildings. There's a cluster 4 is the one focused on the digital and green transition of the industry of construction. So there are some topics under that part. Then cluster 5 is really the energy one. So this is probably most closely related to some of you and the HEART project, including this public-private partnership built for people. But there are other topics in there for funding energy-efficient buildings. And then in cluster 6, that looks more at the circular economy in a general sense, and also bio-based construction and these kinds of aspects. And then also there's the LIFE program, which is closer to the market. It's not research and innovation. It's really direct action. And there's a newly opened call under the clean energy transition part for energy efficiency. And there they have themes like financing and skills are under there. But there are also other areas of LIFE that deal with circular economy and the Bauhaus, the new European Bauhaus. That's all from me. You can see more details on what we do in DG Grow on the website there of our construction unit, and I'd be happy to take any questions if there are any. Thanks.
Just for the questions, on the side of your seat, there's a microphone, and there's a button that you can press. So just check on your left side of your seat. You can open the panel. There's a microphone, and you push the button to talk.
Yeah. Thank you for your presentation. I had a question about the job-generating potential of the renovation wave that you mentioned in one of your first sheets. If I remember correctly, the renovation wave actually mentioned that building renovation is the economic activity with the most potential for job generation. My question actually is, does the Commission also keep track if we have the hands and the workforce available to make sure that ambitions of the renovation wave, of Fit for 55, of Repower EU are actually feasible? Do you keep track, and is there a gap between what is the ambition and what we have as maximal potential?
Yeah, I think that's quite an important question, because obviously we need the skilled labour available to deliver all these ambitious targets. So yes, in a word, we do keep track of this, and we've been keeping a close eye on it right through the Fit for 55, when that was under development, and we had the impact assessments being looked at for these directive revisions. It's fair to say that for some of the very, very high ambitious levels, there was a bit of a concern that we would have the availability there. But this is why, at the same time, we really need to ramp up the upskilling of the workforce. And this is also the reason why we have this transition pathway, because skills and labour availability and also supply chain resilience are important themes in there. So it's very much something we work on. In general, we are going through this period at the moment of very high prices and also lack of availability of certain materials or delayed deliveries and this kind of thing. So it has been a concern. It was particularly a problem recently for wood, because a lot of wood had been coming from Ukraine and Russia, but there were also other constraints elsewhere in the world. But for other materials, less so. So to some extent, also the industry can recalibrate itself and deal with what is available or work with what is available. But yes, it's something that we keep a close eye on. Thanks.
Yeah.
Can you hear me? Yes, I think in both of our presentations we've referred to the sort of change in the environment because of the, let's say, globalization, the difficulty in accessing components, the strain of the supply chain. And we've actually written to Commissioner Breton at the beginning of June to see if there can be emergency measures brought in, because what we are seeing in the social housing sector are specific components that are actually really slowing things. We would be interested actually in meeting with him as a sector to provide more information about what those components are and investigate the potential at EU level to speed up potential industrialization in those areas. Because I think, as we've seen, there's a big gap in our ambitions and what is now realizable, and I think it cannot really be business as usual. We have to step in, and that was one of the urgent areas requiring attention. And in addition, the regulatory blocks in the rollout of energy communities and decentralized of energy production, because although we at EU level the legislation is in place, we are continuously having reports where it's not really realizable on the ground to have local energy production in at the speed that we need it. So yeah, thank you.
Yeah, thanks. I think it's for sure, industrialization has great potential to accelerate some of this renovation, but it's there have been a lot of pilot projects, as we know, looking at industrialization and prefabrication, but we really need to be ramping that up now. We probably needed to be ramping it up a while back already, but it really is getting even more urgent. Another thing that can be done or can help to reduce the problem of improve the resilience is implementing circular approaches, so that we're using more recycled content, we're facilitating the reuse of products, so we're not always importing or even within the EU also extracting new resources. And this is one of the things that is addressed in the construction products regulation revision to facilitate these circular approaches. But again, it's not going to happen overnight. So, we also have to be realistic on what's possible to do in the timescale that we have. I think the point you made about district energy and district approaches to renovations, again, that's a very excellent approach to renovate more quickly and more effectively on a larger scale, especially because you can combine that maybe with district energy systems rather than individual measures. So that's also something that is being addressed in our policies. There's another transition pathway linked to ours, linked to construction, looking at the social economy, which includes things like social housing, which I'm sure you're aware of. So we're coordinating all these transition pathways across the different industries. Another relevant one is the energy-intensive industries and raw materials. So these all come together and converge in a way. It's all happening at the same time.
Yeah, my name is Robert Pinter from the European Copper Institute, and I would like to ask a question about circularity you mentioned, which is really important. And for metals as copper, the end-of-life recycling is very important, and benefits of this recycling, future recycling possibility to be acknowledged in a regulation. And regarding the whole life carbon, it is now in different pieces of legislation like EPBD, for example, but as you said, to disclose numbers. Do you foresee maybe in the future how some thresholds can be introduced time-wise, for example? Thank you very much.
Yes, so you're right to bring up this point. It's one thing to calculate a life cycle analysis of the building and to disclose the number. It's quite another to have regulations setting a maximum amount or a limit value for that. We don't have limit values in the Commission proposals. We're aware that several member states are or have already or are planning to introduce limit values at their level, at national level. And where we've been discussing with them to see how exactly they're doing that. But at EU level, there are no plans to be introducing limit values, at least not in the proposals as adopted. I think that further ahead, who knows? I mean, it might be years ahead, but eventually we'll have to probably see how it works with what we have now before we consider something like that in the future.
Hello. There are several programs that allow to achieve the decarbonization to 2050, so a sort of long-term program. However, I think that we need also some funding and we need some replies to apply even today or tomorrow. What do you think about that? And do you think that there are some fundings that we can apply immediately in order to achieve the goal? Or
well, apart from the two funding sources that I mentioned, the Horizon Europe, which is more for the research and innovation, and the LIFE, which is more for direct projects, there's a lot of money going in different places. There are the National Recovery and Resilience Plans, which are this exceptional money that's been going to member states as a way of recovering from the COVID pandemic. And the member states all submitted plans to the Commission on what they're doing, and almost all of them had a big section on renovation of buildings. And what we've been doing is supporting the member states to ensure that those are effective. And from our point of view in DG GROW, in trying to encourage the member states to consider the life cycle alongside the necessary energy efficiency improvements, which are, of course, the core part of it. So those are going to be rolling out now, these projects from these plans, which are going to be implemented right across Europe. And then of course there are the cohesion funds, which are a different thing again, more on a regional basis. So there's really a lot of funding going into renovation right now, I would say.
Yes, this one. Yes. Thank you. So as the coordinator of the HART project, I have a special question for you. So it is a beautiful project, you understood. But it took, seriously, it took 4 years to be developed. And maybe also the scenarios are changed during these 4 years. So, but it was in line with the policy, with the planning of the union, and at the end, so it was it fits with the programs. But now the situation is very rapidly changed. It is dramatically changed. Everybody knows we have problem of climate change and of energy economy. So now we are developing other beautiful projects like HERT, and also all over Europe there are a lot of projects which maybe will take other 3 or 4 years to be developed. But in the meantime, which is the solution of the problem of today, because of the emergency situation? Have we to wait for 4 years to have other beautiful results like for HART,
or the European Union, the EU, has some emergency strategy also to apply new technology, for example, to improve the biomethane grid or to enforce regulation right now, not within the short period which will last at least 3 or 4 years.
Yeah, you're right. The situation has changed very dramatically and very quickly. This is why the Repower EU plan is probably the shortest term of all, because it's really looking at, I mean, the short-term actions that are listed in there are over the next 12 months. And it's really how can we reduce our dependence on Russian fossil fuel as soon as we can. And then there are the more medium-term parts of that plan, which are things like some of these buildings-related measures, like installing renewables on buildings and the heat pumps and so on, and renovation in general. It's not something you can just do within 12 months. It has a time scale that is necessarily longer. And then, of course, we're always looking further ahead, and this is why the research and innovation programs are really, when you think about having a call and then you have a project funded and then the project takes several years to implement and then the results need to be disseminated, you're looking at maybe 10 years from today. So that's, when you're looking at research and innovation, you can't be addressing today's problems. You have to think about tomorrow's. So we try and do all of these things. There are also all of this legislation under review, which is really a lot at the moment. And we're ensuring that it's all coherent as well, because it seems like sometimes it feels almost everything is under review at the same time. And there's a massive need to ensure that it's all very coherent, which is certainly why we're thinking about how they work together in a consistent way.
Felipe.
Yep, thanks.
I'd like to thank Felipe for the engaging presentation. Now I'll invite Joe for present the Shape EU.
Hello, good afternoon. So I guess I just click here. All right, I will pick up where my colleague Sorka left in the opening remark to remind you that, considering the district approach, why we think it's useful, and the previous presentation already mentioned that, it's this triangle of possibilities, right? Having affordable houses, having enough houses to address the demand that we have at the moment in Europe, and it's reduce the amount of carbon emissions that they are producing, or we are all producing at the moment. And we have heard already in the opening address some of those regulations that also determining all this equation that is, for all of us, it's difficult, but the district approach could be a way to address it. I think at the beginning we already mentioned this. I was going back to this slide again, just to add that the district approach can also mean different things. So it could be in more technological sense, like the example already mentioned of Potsdam. It could also be about giving the community the resources to manage their own energy, for example, like this case in Bordeaux, and also the holistic approach. So not only considering the physical generation of a place, but everything that is involved in creating a thriving community. So, okay, now let's go to the district approach that we are involved in as Housing Europe. It's mentioned in the renovation wave to make the social housing sector also benefit from the renovation wave. It's actually a paragraph where they mention the affordable housing initiative. And the purpose of this affordable housing initiative is to pilot 100 districts to serve as an example and be replicated across Europe, so that other owners of social housing can use those blueprints, those examples, to do the same, or at least be inspired by those blueprints for replication, as it is mentioned in that paragraph of the renovation wave. And of course, very important, setting livability at their core. This is just to say that there are, in all projects, of course, there are a lot of linkages to be done. In this case, one of them is to the new Bauhaus. So when we are thinking about all these three different approaches, the district approach, we can also start thinking about how those houses should look like in the future. This is the new Bauhaus initiative. And of course, there's the financing part of the Affordable Housing Initiative that at the moment, it comes from the Horizon Europe calls. There was already a round one. And we should have them getting started in September, October of this year. There are 3 projects there. But my project presentation will focus on that part there, that half of the Affordable Housing Initiative called the European Affordable Housing Consortium, or SHAPE for short. Basically, we are a partnership of European level organizations, and we intend to provide technical assistance to local actors. This is the entire name of the project. So yeah, so we will provide technical support to SMEs, to the main actors that are involved in this planning and building renovation of projects. So the SMEs in the ecosystems that were also mentioned in the previous presentation, public authorities, and of course social and affordable housing providers. We will support them in their planning or their implementing, delivering those renovation projects. And like I said, those 3 examples that I mentioned before, we don't want any kind of projects to be planned or implemented. We would like to be a bit different, innovative, that can address the challenges that we have at the moment. So they could be smart, circular module renovation approaches. We saw before the advantages of this more prefabricated, industrialized approach as well. The people-centered models, giving the people the tools to manage their own destiny or their energy as well, and the co-creation and engagement practices. So let them get also involved in the planning and implementing of the renovation projects. And of course, those 3 conditions, the Affordable Housing Initiative is of course focused on social and affordable housing, focused on the district approach, and innovative, so lighthouse, to show the way to other projects throughout Europe. This is what we are doing and what we intend to do in the future as well. So it's a very short project. It's not about research on innovation, although there is a lot of gathering being done. Desk research and also other kinds of work that I'll mention shortly. So first of all, we are creating a hub of knowledge. So a one-stop shop or a single point of information on anything related to planning and implementing renovations at the district level. With all that information, we're going to create draft blueprints for these innovative districts, to this district that will show the way. The how-to, guidelines. They will be very practical, supported by examples that we're going to collect throughout Europe, including the HEART project. It's already there in the catalog. And with all those guidelines, we will ask support for the leaders, the project leaders of these examples that we have been collecting, and ask them to provide mentorship to other organizations that would like to know more about these different approaches, be it technological, technical, community-driven, or co-creation practices. We will have them meet and share their knowledge, tacit or codified in the hub of knowledge, in a series of events. And then we will try to learn from the project and also recommend the policy changes that are in some framework, favorable framework for those projects to happen further and more across Europe. This is just a list. I have 3 slides. So we will draft 3 different kinds of blueprints of how-tos on 3 different topics. The first one is this one, is the project implementation part. There will also be the social innovation part and the more technological components of these projects. As you can see, it's very practical. What we will have is to ask questions and then try to get the answer, the solutions from across Europe. So for example, how do we provide temporary accommodation for tenants during the renovation period? So when there are construction works inside the house, how do social housing providers usually solve this problem? How do they keep the residents lodged? Also, how to deliver SME-friendly partnership procurements that actually are enabling of innovation in the renovations. How to attract private capital to financially sustain the renovation, not only providing public support, but also including private capital in those fundings, etc. So there are a lot of questions that we have at the moment. There are challenges that we are trying to get some interesting solutions that can be available to disseminate throughout the social housing community. These are the questions of the social innovation, and of the technological and technical considerations of the blueprints. So the blueprints for replications, like I said, are based, or will have support of the best practices happening throughout Europe. We will also have an idea of what gaps and problems project leaders in social housing are facing at the moment, so that those blueprints, they don't go, they are not spread across a number of topics, but are focused on the ones that are more relevant. And we'll also provide some a mapping of available funding. We'll also have a simulator so that any project leader that is aiming to fund their renovations can find some information, some direction there. Then we will use this diagnostics, this needs analysis, and working with experts in the field, we will draft the blueprints for application. It will be a very interactive process. We will use the network of all the partners, and we have 4 organizations that are European networks at the European level, to collect their feedback and experts, so that these blueprints are relevant at the national or even local level. And then those same experts and practitioners will provide this mentorship, the peer-to-peer support to other peers that would like to get this tacit knowledge from these experts. All this, like the single point of information, will be available at this website. It's still under construction, but I guess you can already keep it as a favorite when it is available finally. So it will be quite simple, just something about the project, how to get support if you are willing to plan and implement a district level approach. If you want to receive this mentorship program support, you can just go there and register, and we will hook you up with the mentors, the ones that have the knowledge that you are looking for. Finding Inspiring Example is basically our catalog of practices, policy solutions, where we're going to feed in all the information from our own policy lab. We will discuss all the policy implications from the practices that we have been researching. And obviously, Join the Movement is about communicating and disseminating the information that we get. So throughout these 2 years, we will be across Europe. So there will be a series of events across Europe, mainly regarding this mentorship program. It will basically be a one-on-one meeting in Paris, Vienna, and Barcelona. But we will also have online events, like webinars on the financial matters of renovations, online training on the blueprints. So we will ask the experts to provide that focused training in those solutions to the questions that I mentioned earlier. and we will have site visits. So the next site visit will be in Tallinn. We will be checking their approach there on the industrialized solutions to renovation. I would also like to make it a bit more concrete. So I actually had the example of Hearts as the first example, but as it is the Heart conference, I will not present it. But this is an example, one of the practices that we'll be feeding from regarding the energy communities. So if you give the possibility to the tenants to manage their own, the production of energy and their management, what happens is the reduction of energy bills, and they actually build a culture of saving, which is more important than just reducing the carbon emissions for some time. This is also another example. This is about co-creating a renovation project. So in Berlin, in the Netterbachplatz estate, they didn't only began a renovation process with the community, they actually asked the community what kind of community you want in the future, and let them help the architects, the engineers, design the community that they want, the estate that they want. And you see some of the results, they're actually talking about it. There were a lot of discussions, but they sound quite happy about it, so it was a productive discussion. And what ended up in the end was what I have there. It's a striking example of the cooperative architecture in the district form. They actually added all the ground floor were dedicated to common facilities like gym, community halls, common urban gardens, which probably the architects and engineers didn't think about it if there were only ones planning the project. And of course, we also have some idea that we have the notion that it's just not about implementing projects from zero. We need something in between. And this is why we are also looking in terms of policy context. What can we do also to help them reach these really interesting projects like the one in Berlin? And I have some examples of what some organizations are doing to help those providers do it. So this is, for example, a catalog of renovation solutions from the Netherlands. So it just catalog of market-ready innovations that you can use in your renovation efforts. This is also a very interesting initiative in Sweden. It's ready-to-use procurement processes. And yeah, so in Sweden, if you would like to renovate your building quite effectively, you just use these procurement templates, and you have everything necessary to do it. Yeah, that's it. Thanks very much. Any questions?
Very quickly before we start off, I'll be moderating the event. Carlis Goldstein from Cabinet Simpson's team. I'll do a brief intro because you've heard from the Commission people before, and then I'll head down to our distinguished panelists. All of you have read the headlines, of course, so we are dealing with quite a dynamic age right now. And I'm one of the panelists that will need to leave as well to try and resolve some of the challenges, so apologies for that. So what we have on our hands is really a universal, a broad and profound, not just transition, but transformation of the energy system, I would say. It's important that we look at the buildings, because you might know that they have a very significant footprint in terms of energy consumption and also greenhouse gas emissions. Plus, as we've just spoken, is that if we look at the generation side of things, we've been investing for more than 150 years in it. On the efficiency and building side, yes, but not systematically, not as a policy field. So I would say that looking at it from the European Commission's point of view, it's really the up and coming and increasingly important part of the European energy landscape. So for those of you who have either dealt with renovation or who are dealing with it professionally or privately, it's a very complex topic, and this is why this HART project is a very good example of how to simplify things. And we really need to go beyond having a Gantt chart on our hands and talking some policy. So maybe as an opening, and I'll start with Sorka and then pass on this way so that you know. From the perspective of your respective organizations, so it goes out to all of you, what is the significance for you of high-performance buildings? Why do we need them? What's the use? Renovation will cost time, it will cost money, and investment from the building users. So what would be the main benefit? And we'll start with Sorka and then pass on.
Thanks, Carlos. You're always good at making us look at this with a different perspective. Indeed, we've seen the figures in terms of why we need to address the carbon footprint of the sector, and of course why we need to address the wasted potential of the sector as a part of the energy production system, so with renewables. But I suppose from our sector, what's also very strong when we speak to the local housing providers on the ground, for example, I spoke with one last week from quite a former industrial area of Gran Canaria, and in that particular renovation project which transformed the neighborhood, it was actually a person he spoke to, a couple, elderly couple, where the lady in the couple was actually hadn't gone out of the house in some time, and the renovation meant, so the energy retrofit, which included a lift, because it was a 4-story building, actually had transformed that couple's life, because now they were able to go outside for a walk in the evening, see other people, and that for me was a really hard-hitting story. We also hear now of people who were not able to work from home, for instance, because the homes were too small during COVID. A renovation could mean extra space so they can actually do that, so that it doesn't compromise their professional career. It can mean a neighborhood with, while the renovation was being done, extra green spaces, which can also absorb, let's say, if it's done well, absorb excess rainwater, but also provide places for young people, so they can have more, let's say, aspirations, also more opportunities, access to potentially, if we look at some of the projects João presented, increased access to services in the area, if we look at a cleverly done district renovation. So I see it as an opportunity to address the urgently, the fact that most of our buildings were built in another era, and an era where we had cheap energy, and there was no realization of the threat it poses to our civilization, to address that, but also make sure we use it as an opportunity to transform people's neighborhoods and people's lives, and not miss this opportunity. Thank you.
Thank you. That's a very inspirational story. If I can now turn to you, Robert. First of all, a lot of the solutions will require copper. So a semi question and then the full question. First of all, do we have enough of it? And then the second question, leading to the same as I asked Sorka, what is the importance of building renovation for you?
Thank you very much, and thank you for organizers for inviting me for today. And yeah, it was a very, very good event, and I like especially in this HART project the first word of holistic, yeah, which means that you really, acknowledge more aspects of the renovation. And now coming to the question. So I represent the European copper industry, which is a leading advocate of the copper industry in Europe. And our members mine, refine, smelt, and recycle copper. And yeah, copper, thanks to its excellent electrical and thermal conductivity is quite used in buildings, and wherever electricity is generated, like in renewable generation systems or transmitted via wires, but the same for the heat exchangers, for example, thanks to excellent heat characteristics. So basically we have one energy system which is interconnected. The industry, the buildings, transport use the same energy system. What we save in industry will be available for buildings and transport, and of course vice versa. And my feeling is that industry is a bit more ahead of energy efficiency measures and transition compared to buildings. Energy management systems are quite common in industries, and thanks to ETS, for example, I would say that low-hanging fruits of energy efficiency in industrial sector are already harvested. But my feeling is, and today we have heard that in buildings you can achieve 90% energy saving still in worst performing. So I can say that in those low-hanging fruits are still there in case of buildings, which we should somehow, grasp the opportunity and really, harvest them and lower the demand of our one and single energy system to benefit all. And the very last one about availability. Today we heard the keyword of circularity, and this is maybe the key answer to availability of copper or other materials. We should build the renovation wave and all the Green Deal based really on circularity, the reuse and recycling of materials, and in that case all materials will be available. Thank you very much.
Thank you. Julie, may I turn to you, because you also deal with a sector with very high recyclability potential, which is windows and aluminium frames. So a question to you, as I asked Sorka and Robert before, what is the importance of improving buildings for your case, from your organization's perspective?
So thank you very much for inviting me, first and foremost. So my name is Julie Kestrup, and I'm from Buidings. And for those of you who might not know us, we basically produce sort of rooftop, window and dome solutions, mainly for the residential sector, but also for commercial. And I always tell people that I lobby for daylight and fresh air. So, that's nice topics, I think, to work on. So I think you said a lot of good things already. And I think you, Robert, said holistic, and that's also one of my favorite words, followed by multiple benefits, which Adrian was going to say if I didn't. Because I think the importance here is that there isn't one reason. There are a lot of different reasons. And I think also we've all sort of talked about the context here. 3 years ago, it was all about Fridays for Future, it was about climate, it was about sort of youth on the street. Then came Corona, and it was all about sort of using energy and renovation as a way to sort of recreate basically economic momentum. And now, of course, we've got the invasion of Ukraine. So I think my point here is that energy efficiency and renovating the building stock is relevant for a number of different reasons. But we should work on all of them together, because the good benefits of doing that are constant. And so I think that's one thing that's very important, that we remain true to that. And then in terms of what we can deliver, and again, I think Zolteri mentioned it a little bit. I mean, from our perspective, a big thing that we don't talk a lot about, but is essential for all of us, is health and well-being. So typically, we talk about the energy efficiency side of things. That's also what we can see in the EPBD, for instance. But what we're undervaluing is the impact on overall health. And now we know that there's a direct correlation between having a good indoor climate, for instance, and people's overall health for allergies, for more serious issues. But we've also at Buidings commissioned some research to look at the well-being benefit. And well-being sounds a bit sort of flimsy, maybe, but well-being actually translates into productivity. It translates into better results in schools for kids, and so on and so forth. And the numbers there that can be tied to energy efficient renovation of building stocks are absolutely huge. We did some recent data that suggested that 1 in 3 Europeans actually lives with some sort of health and well-being hazard within their own confined space. And to your point, I think one thing we've all learned over the last couple of years is the importance of living and operating in a space that is comfortable and makes you feel good. I, for one, have sort of I spent the first 6 months looking towards the wall in my home office, in my living room, thinking I wanted to minimize, the impact on the overall building. But I then realized once I turned around and actually looked out inside towards the world, that the physical environment of where you're in has a very big impact on how you perform and how you feel, and therefore how we all go through life.
Well, from these very divine topics of air and light, we come to Adrian very appropriately. So I'd ask the same question I've asked, which is what's the importance of building renovation for your sector? But I will add a small twist onto it. And I will ask, what should be the main reason? Because you mentioned multiple benefits, Julie. What should be the main reason to renovate? And who should be the one telling people what that reason is? Adrian.
Thank you, Carlos, and thanks to the HEART project for inviting me to join this panel, and hello to all the online participants. There were more than 100 this morning, so a good crowd are listening. I also, like Robert, like the word holistic, so your question is unfair, Carlos, because you've asked me to point out the most important reason. And actually, over the last 25 years or so that EuroAce has been in existence, always calling for highly energy efficient and highly energy performing buildings, we have always tried to highlight the multiple aspects of why it's important rather than the overriding one. Because I've witnessed debates where questions have been asked, should we back winners or should we go for this more holistic approach? And I see a bit that reflected in your question. And I think if we end up backing winners, it'll be because of a political imperative, not a technical imperative. Because in any good building that's highly energy efficient and performs really well over time, you have a very good combination of measures from the fabric through to the equipment and onto the controls that work harmoniously together for the well-being of the people in the building. And this is really the meaning of holistic. But if I could, I'd like to go back to your first question, which is for EuroAce, what's the most important aspect of having, or of this moment in the debate around energy performing buildings? And I was tempted to just speak in regrets, saying that 10 years ago we were saying the same message and nothing was happening. And now we have at least a very informed political discussion at all levels due to the urgency and the gravity of the energy security question. But for EuroAce, I think the main thing would be upscaling. How can we upscale the rate and the depth of renovation taking place across Europe? And I'm hopeful that the HEART toolkit, which is marrying a lot of these aspects together, will be another great element in our collective effort to move forward. So, in full awareness of all the challenges that were discussed, and I think there's full agreement, not just in this room of informed people, but in society at large, that our wasteful buildings need to be addressed, and that the target of highly energy efficient and decarbonised buildings by 2050 is the right target. So it gives us our lighthouse towards which we can direct ourselves. But we've known this for some years, and we still aren't seeing that uptick in activity. So I have an idea to put to the audience and to the project. And it initially maybe seems a little dry as an idea. And maybe Philip would be well able to talk to this from DG Grow. The idea is to define a new industrial activity called energy renovation of buildings. Now, why do I say we should have a new industrial activity? It's because I see a need to uncouple in the renovation sector from the thinking of new build. I see a need to uncouple from the traditional sequential approaches that we take to new build work. which is the main concern of the construction sector as such, I think we need to uncouple now from pilot and demonstration projects, because we've been doing them for 25 years and we know it all works. We know we have the technologies and the materials, and so it's time to uncouple from that thinking and upscale. And I would like us to uncouple from cost effectiveness as a phrase or word in this sector, because the multiple benefits that arise from having healthy, highly performing buildings are significantly greater than your straightforward return on investment economic thinking, which has dogged the renovation sector for, decades. And given that political imperative of energy security, cost effectiveness shouldn't be a question you ask, in my view. You should be deciding for society at large, the right thing to do is to renovate all of the buildings. And I loved the story from Zhao about the district approach, because it is at district level, I think maybe we can upscale quickest. So if we did that, and then I'll stop. The positives, I think, of having a new industrial activity called energy renovation would be that we would see more collaborative thinking. We'd see more meticulous technical assistance being rolled out, because it's a very different approach you take to a renovation project. We'd see more industrialization of the process. I think we'd have better results and a more attractive sector for young and female workers to join. We can roll out and benefit from digitalization and mass customization in factory settings for prefabricated panels, etc. We can develop tools which I think are in the HEART project to gather the data of the performance during the life of the building, using predictive maintenance and feeding back into the new districts that are going to be renovated, the learnings from the previous ones. And hence, of course, new business models, I think, would emerge, and maybe even venture capitalists would be ready to venture their capital into new businesses in this new sector called energy renovation. So these are the thoughts that struck me as I prepared for the panel, Carlos.
Thank you very much, Adrian. And we'll continue with a second tour of questions, again starting with Sorka, because I know that she will have to go at some point. Before I do that, the audience might know that there's always sort of a duel kind of relationship between the European Commission and the stakeholders. I think it's more of a duel in this particular instance, which is why I was very happy to hear the mention about holistic, the way that you responded there, because at an event about one-stop shops, really essentially in the Commission's understanding, it's essential to put these different aspects of energy use in buildings together. And I wish I could see more, let's say, private and public partnerships. So we're seeing that there can be different models, but there's definitely something to learn from both the public side to bring into the picture and from the private side to bring into the picture and to commercialize it. And maybe turning it into a DG Energy or Energy Commission portfolio debate, for us it's really about maybe enlarging the picture even onto energy peak demand management. So it's really about making sure that we lower the overall energy consumption, but also that it doesn't become unmanageably fluctuating, the energy consumption at any given point in time, because that would simply stress the system too much. Coming back to you, Sorka, I'd like to ask you, so there's already some funding and regulation and legislation in place. Do you think it's sufficient for the required ambition? Do we have enough to boost innovation, decarbonization, and affordability in the sector? And we have about a dozen minutes, so I'll ask everybody to stick to about 3 minutes.
Indeed, the financing question obviously is a difficult one. When we speak about the 350 million units that we have under the renovation wave that we've committed to renovate by 2030, I think there are definitely we can see quite a lot of gaps. But I would like to maybe just refer to a specific study that we did within our estimate of renovating 4 million units by 2030. And I must say that was pre-Ukraine forecasting. But we estimated that in addition to the 23 billion that is being invested annually by the sector, so by the public social cooperative housing sector, we would definitely need an additional injection of 13 billion to reach a standard of C within the sector. We see that it's the way the rollout of the Green Deal ambition. The dynamic is quite different to what you would generally see as a program of rolling out energy efficiency at national level, because there you would set an ambition, you would put the financing in place, and then the housing providers would then apply for that finance. However, what we are seeing now with this dynamic, we are seeing obligations or targets being proposed without necessarily the funding being in place at national and local level. And this is what can generate tensions. Obviously, the Climate Fund has a potential to fill part of that gap, but it is still very far from the target. So we see the potential of the ETS2, we're talking about what income could be generated there by applying the ETS to buildings. However, the tax that has to be imposed may already accentuate the affordability crisis that we are seeing in the housing sector before we can correct it with the Climate Fund. So I think there are clever financing systems on the ground that are being rolled out. And I liked your questions saying who should be telling who what to do. And I think that is really where we have to start. Look at those clever finances systems that have been rolled out, whether that are revolving funds, additional public guarantees, subsidised loans. Look at where they have actually really brought a massive upscaling of renovation, and then work on seeing how we can replicate those. So making sure, for instance, that we have limited profit, public guaranteed funding in place across the continent, because there we see that's a real success clincher, but still lacking in many cases. In your country, Carlis, in Estonia, we see that thanks to the CredEx National Fund, working together with structural funds and the Council of Europe Development Bank, they managed to put a system in place to provide very low interest rates for homeowners, and that fund is emptied early every year because there's such a high demand and it's rolling out. However, that financial infrastructure which serves to reduce the cost of finance for end users is missing in many cases. So I think, yes, there is a gap, but yes, we also have the clever ideas where we can step in and address that gap.
So thank you, Sorka. It basically means, in my interpretation, that the Commission has done well in putting in place regulation, at least, so that we have some sort of predictability, hopefully when the legislation becomes adopted, about the direction of travel. However, you also said that we're not quite there in terms of funding. And then my heart almost stopped, but then I realized that the Commission has left member states the freedom to choose which tools to actually put in place.
And of course, the key point is also flexibility according to the context. So as I mentioned, this example where we spoke to social housing providers in certain parts of Europe, like Gran Canaria, it's an exception. However, shading is a big priority, whereas energy efficiency would be less so. Shading, cooling. So we need to have the skills, and Repower EU has given, as announced earlier by DG Grow, a big focus on skills. But I think we have to bring that even further, because we need the proper skills on the ground to put the right strategy in place for each district. Because if we are too descriptive about the precise performance that each building should have from the European Commission level, I think we can have a backlash because the wrong instructions will be given, and those instructions would be followed because there are criteria to access the funding, but it might not be the best direction for that particular district, and we do see that happening in some cases.
Very interesting. Robert, coming to you, I'd like to know what's your take on the predictability angle. So does the current situation provide enough predictability for the innovative solutions to be deployed in buildings? And thank you very much, Sorka, for being here.
What do you exactly mean by current situation?
So the legislation that is in place, okay. Basically.
Yeah. Given the time frame, I would like to concentrate on one thing, namely what you mentioned, the energy peak demand management. This might be, in my view, in case of buildings, a little bit better regulated. EPBD has done a great job since decades, since at least 2 decades, on energy efficiency. It has improved quite a lot. Then the next leg was the renewable generation in buildings. This started 5 years ago, and it's quite taking off. And the next one, in my view, is demand-side flexibility. And this is not enough or not properly regulated at the moment. What I mean is, for example, to develop a kind of metric where you really quantify how much time, for example, can your building live without grid electricity. And that's really, really important, you know. If the bigger number of electrified buildings we want really to handle at European level, this is key. So demand-side flexibility, peak shaving, and storage. Yeah.
Thank you, Robert. Turning to you, Julie, I know there are interesting potentials for windows, basically, to help improve the energy profile of a building, for example, through ventilation. And maybe you can tell us a little bit about that as well, and about the innovative solutions that your industry can bring to the table.
Sure. So, I mean, we produce windows, which in itself is a pretty simple project, you can argue. But what we see more and more, and what we're working more and more on as Velux as well, is to have smart window technology that, for instance, interoperates with control systems so that it can measure indoor temperature, indoor quality, and regulate accordingly. So that's one of the ways we're going in terms of a smart. As it stands, it's still a relatively small business, but we're seeing that grow as well quite rapidly and expect it to take up a bigger part of the portfolio going forward. But then I think sometimes in order to talk about sort of smart, we also forget solutions that are really simple. For instance, when we saw the EPBD recast that came out, there was a lot of talk about mechanical ventilation, but they hadn't actually mentioned manual ventilation. Now, what's that? That's opening a window. That's totally free. It comes with a window. It cannot, if you live in southern Spain for sure, replace air conditioning, but these sorts of sort of side products of a different product can actually make quite a big change overall. We're just going to face a heat wave next way in Belgium here with degrees of 40 degrees, and we know that just ventilating your room properly, for instance, can actually fluctuate the temperature of the room 2 to 3 degrees in either direction, which again, if you then combine it with smart systems like, for instance, air conditioning, will overall create a pleasant environment but at a lower overall cost. And I just wanted to mention, because I think you mentioned before these sort of low-hanging fruits, and it's something we like talking about here because it sounds so good, right? It's quick and it's easy and then we're done. But I think we really, another word for that is sort of whack-a-mole. You know those games as a kid where you sort of like a mole comes up and you whack it and it goes down. Like your boiler is no working well and you get a new boiler. And we really need to get back to this concept we're all talking about, which is like holistic, to make sure that when you're replacing one component, you're not just getting a like-for-like replacement, even a better version of it, but are also doing the other elements of it. And that's also why, to your point, Carl, is I think this idea of the one-stop shops that again exist and need to be tailored to the local context are so important, because we know today from plenty of research, both some question elsewhere, that people just don't know where to go to get that holistic approach. And that makes them give up, and then they replace one bit that's faulty, and then we're back to square one. So I think that really is a major issue for us to tackle.
Very good, Julie. And with you, Adrian, I would like to stop for a moment on the smartness of buildings. Paraphrasing what Julie just said, do we need to move from whacking a mole to capturing and mastering the mole? So, in other words, how can we better roll out the flexible technologies? Is that where the European competitiveness lies as well, making the systems work together? Some people say there's considerable potential there.
Yeah, I can start by agreeing that there's considerable potential in what's called smartness, and the Buildings Directive, as it is today, has the Smart Readiness Indicator that has been developed, and a proposal now to integrate it in a more obligatory manner moving forward is on the table for discussion. And indeed, smartness or digitalization of how we use our buildings has great advantages, in the sense that by allowing the user to have more information about their energy use patterns, they can make informed decisions about how to change that, including to engage in demand response programs such as those mentioned by Robert. Secondly, the correctly smart building will know when the peak demand of energy is coming and should be able to turn off certain machines within the building to avoid or to reduce that peak for the entire system. And these technologies exist today. And lastly, a really smart building is interrogating, let's not use the word talking, it's too human, but interrogating the conditions in the grids that it's relying on and adjusting energy use within its own field, within the building, to respond to that over time. And all of these approaches are available in the market. They're more used in commercial buildings than in residential buildings. But because 75% of our building stock today are residential buildings, it is a good idea to think about how to roll these technologies out into that larger portion of the building stock. But I have a worry, Carlos, and you as a policymaker will be interested in it. I worry that the way we think in the policy circles about how to regulate for smartness or for a better rollout of digitalization is lagging behind the pace at which these technologies are developing. And I would have a worry that unless we're very careful, and I don't have the answer sitting today, unless we're very careful in how we phrase the elements of the Buildings Directive around digitalization and smartness, they might become in 3 or 5 years a shackle on certain approaches that could be really, really useful for predictive and preventative maintenance, for example. Because I don't think we need to capture and control the mole, but I think we need to understand what the mole's next move will be and then anticipate so we don't end up with that whack reaction. The worst thing that can happen in today's situation in a residential building is that your fossil fuel boiler breaks down in the middle of winter, and in panic you simply replace it with another fossil fuel boiler, because then you're locking yourself in for 15 to 20 years to that fuel source. And if we had more predictive maintenance where you're warned that the life cycle is about to come up, end, for the service life of your products, you can plan to have the money ready to go to the right solutions for the future. So taking steps today that do not undermine our possibility of achieving the long-term goal is really what I'm talking around. And we can do it. I'm thinking about this question about how do you write a regulation today that will still be appropriate in 5 years' time in a sector that's developing at a galloping pace. So maybe we need to knock our heads together on this with some technology companies as well.
Very good. Thank you very much. I believe this brings this discussion to an end, and my takeaway would be that if you're heading into your winter, and available, then do check that your technical systems are up to speed, properly calibrated, and that you're not going to face a day or two down because of malfunctioning equipment. So with thanks to this, applause to this distinguished panel. And I hand it back to the organizers, please. Thank you.
We'd like to thank you, all the panelists, and Carlos for moderating the session. We'll also like to thank MP Kelly, who initially had offered to sponsor this whole event and wanted to be part of it, but due to the conflicting schedule, he couldn't. But he had a video message for us, and we'd like to play that video now.
Dear Recorder, let me begin by thanking the HEART Consortium for inviting me to speak today. Although I unfortunately cannot be with you all in person, it is my pleasure to open the third session of today's event on the topic of the EU's role in promoting smart and flexible technologies. The EPBD is a key piece of legislation in the European Green Deal, and its revision will have wide-ranging implications for the EU renovation wave and the EU's climate goals in the coming years. This file is part of the Fit for 55 package, but as it directly involves living and working spaces, it will essentially impact every citizen across Europe directly. The revision of the directive introduces new standards for energy performance to decarbonize the building sector, with changes to definitions of energy performance standards, revisions to national building renovation plans, and a new requirement for life cycle emission calculations for new builds. Considering the massive contributions needed to meet the EU's climate and energy targets, it is high time this sector got some real attention. Between 85% and 95% of our current building stock will still be in use by 2050. Therefore, retrofitting is an essential component of the move towards a greener building stock. The renovation wave will help to create job opportunities for young people across Europe, as well as contributing to the achievement of our climate goals. Soaring energy costs in Europe in recent months have also highlighted the practical need to reduce energy consumption and improve the energy efficiency of our homes. It is clear that building renovations must consider cost effectiveness, local circumstances, and the diversity of our building stock, and respect the principle of technology neutrality. Training and education is a member state competence, but renovation plans should include quantitative and qualitative assessments of the current market needs. For skilled professionals in the construction sector, using key performance indicators such as the number of companies that provide training, apprenticeships, etc. This should also include use of digital technologies, because the reality is that such technologies will play a bigger and bigger role in the future. A coordinated and clear effort by the Commission and Member States to address the issue of skills will be imperative to its success. Member States must invest in capacity building, technical assistance, and upskilling and reskilling policies in order to realise both competence of the green and digital transition. In my amendments to the EPBD, I have included many aspects to promote further the use of energy-saving technologies. These are cost-effective solutions with a high yield on return of investment, allowing us to utilise much better primary energy consumption. In my view, Member States should also encourage the development of 3D digital representation and modelling analysis in the initial design phases to enable the study of more efficient design alternatives through energy and and carbon analysis. Energy performance certificates, or EPCs, are an important awareness tool and have a large potential to improve the performance of buildings. EPCs should integrate information about the latest inspection of electrical installations and their readiness to install necessary green technologies. We should also consider how national inspection regimes of existing electrical installations in residential buildings are included in national building renovation plans. EPCs should be easily understandable, with all relevant information needed without requiring unnecessary reporting obligation, but they should include primary energy and final energy to increase the accuracy of the information. This should open the door for further use of real-time metered energy data, an industry that will likely grow in the coming years. Lastly, through the EPBD and the Data Act, we should ensure a secure framework for energy-related data transfer, which will be an important factor in the optimization of buildings' energy efficiency. Excuse me. The data of a building should be structured to enable interoperability among technologies and better use of the data collected. The costs associated with collecting data must be proportionate and foster a sustainable business model for all parties. These are the main points I would like to mention. I hope you enjoyed the rest of today's discussion, and thanks once again to the HEART Consortium for the opportunity to contribute. Buin tahanef asan kidele den law. Mille buiches.
I would like to thank everyone for joining us today.